Students, you were born to win. You were born to win. But to be a winner, you must plan to win, prepare to win, and expect to win. So, my shimmering stars, I welcome you all to this amazing platform of Physics Wallah. I, Shaurya, is going to start Organic Chemistry's first lecture. That is going to be IUPAC Nomenclature. Basically, students, organic chemistry, students think that it is kind of a tough subject. But I assure you that when you are going to finish this lecture, you will be able to understand how interesting is organic chemistry. You are going to learn how to name organic compounds. Either it be complex compound or it be a simple compound, you will be able to name it in a few seconds. So now let us begin towards our very first topic. First of all, we need to understand what is organic chemistry. Then we will move forward one by one from the basic to the important topics that are going to come in your examination. So students, from the very basic I am going to start, that is what is organic chemistry. So according to the history, there was a scientist known as Berzelius. According to Berzelius, he gave a theory, that is vital force theory. I am going to repeat it. He gave theory that was vital force theory. Now students, according to this theory, organic compounds are basically prepared from living plants and animals. But after some time, what happened? Different scientists came and they showed that it is not true. Why it is not true? Scientists like Wohler, I am repeating again, this was given by Berzelius. And the another one which I am talking about is scientist Wohler. He told us that no, organic compounds are not prepared by living plants and animals, but it can also be prepared artificially. He proved that it can be prepared artificially. He took ammonium cyanate, students. What he took? Ammonium cyanate, which was NH4 positive, CNO negative. Okay, this is ammonium cyanate, which is an inorganic compound. Now, as you know, vital force theory told that organic compounds can only be prepared from living plants and animals, but it was not true. It is considered here that from inorganic, that means for artificially also organic compounds can be obtained. How? See, Wohler took ammonium salt and he observed that with the help of inorganic compound, he obtained what? He obtained urea. He obtained urea, the very first organic compound, NH2 C double bond O NH2. Now this is what? This is urea, the first organic compound prepared artificially. First organic compound prepared artificially. Clear, students? Now, hence we got to know that organic compounds can be prepared artificially. But students, is it the correct definition for organic chemistry or organic compounds? No. If I come to define organic chemistry, first of all, I need to understand what are organic compounds. So if I talk about what do you mean by organic compounds? Organic compounds are the compounds that are hydrocarbon, and its derivatives. Now, what do you mean by hydrocarbons, ma'am? Hydrocarbons are basically those compounds in which we are going to see carbon as well as hydrogen. In simple language, I will say that. And what are its derivatives? Derivatives are the one from which we can derive other organic compounds, with the help of which we can derive other organic compounds. So I would say organic compounds are those compounds which are hydrocarbons. That means these are those compounds which contain carbon and hydrogen. It is the basic necessity condition. It should contain carbon and hydrogen, but one more thing, it is added in the definition that along with its derivatives, that we can derive more and more compounds with the help of the hydrocarbons. Now, what is organic chemistry? Organic chemistry is the study of hydrocarbons and its derivatives, or I would say it is the study of organic compounds. So if I am going to define organic chemistry, I would say it is the study of hydrocarbons and its derivatives. Okay, clear? Now we got to know what are hydrocarbons, what are organic compounds, what is organic chemistry. Now we will move forward towards our next segment, my dear students, that is going to be classification of organic compounds. How we are going to classify these organic compounds. Now we got to know organic compounds are the one that contains carbon and hydrogen and its derivatives, right? Now they are classified further into two categories. One are the open chain compounds. Now please listen to it carefully. One are open chain compounds and the other one are closed chain compounds. Okay, so we have seen there are basically two classification, open chain as well as closed chain. Open chain refers to what? Kindly mention it so that it will be easy for you to understand it. If I talk about open chain compound, in other words, I would say when first carbon atom is not attached with the last carbon atom, So I would say this is open chain compound. But when I talk about closed chain compounds, I would say these are those compounds in which first carbon atom is connected to last carbon atom. So I would say when first carbon atom is connected to or attached to last carbon. Clear? I am directly writing carbon as C. You know that we represent elements, right? So I have written directly as carbon as C. So when it is not connected, it is open chain. When it is connected, it is closed chain. Now I'll give you one example so that it will be more easy for you to understand. I am taking an example of CH3, CH2, CH3. Now what do you observe here? You observe that basically there are 3 carbon atoms here. Forget how many hydrogens are there. I'm just talking about carbon atoms so that you can understand here what I'm going to explain you. And if I talk about the closed chain compounds, let us take one more example here. I say this. Now, students, one by one, you're going to understand what is the concept. I have drawn this in such a way and I have drawn that in such a way like a triangle. Now, for the very first time, I am calling it triangle, but after the IUPAC nomenclature, its name is going to be changed, right? All the chemistry students are not going to call it as a triangle if you are a chemistry student. We are going to name it in a certain way. I am going to tell you the rules, so it will be very interesting for us to understand. First of all, let us see open chain compounds are the one in which first carbon is not attached to the third carbon. This is not attached. This is first, this is second, this is third. Now, many of the students will say that, ma'am, why not start the numbering of carbon atom from this side? You can do. There is no such, concept applied here that I am starting from this section or from this side. Further, you are going to see there are some cases where we have to see the direction from which the numbering are going to start. But in this case, when there are 3 carbon atoms and there is no such extra group attached to them, so we can directly use any of the direction to number them. Now here, first carbon atom is not attached to third carbon atom, hence it is open chain. Now if I talk about closed chain, what I'm going to observe is, this is basically a bond line notation. when we represent carbon in a different form. You know, when we are going to represent this, I'm going to explain you the bond line notation also, but first of all understand here. Basically, if I open this bond line notation, I observe these are the 3 carbons present here. Now, if I number these carbons, it is going to be the very first carbon, this is second and this is third. Now, what do you observe here? That first carbon is attached to the last carbon, that is the third carbon. Hence, it is a closed chain compound, or I would say a ring is obtained. Clear? Now you are getting the basic difference between open chain compounds and the closed chain compounds, right? Okay. Now further students, when I am going to classify open chain compounds, it is further classified into 2 basic subcategories. One is saturated compounds and another one is unsaturated compounds. Now what happens, students, if I talk about saturated compounds, these are the ones that are known as alkanes. And in alkanes, what do we observe? We observe that carbon and carbon are connected with a single bond. Carbon and carbon are connected with a single bond, that is known as saturated compounds. But when I talk about unsaturated compound, students, then I would say that these are further classified into 2 basic subcategories. One is alkene and another one is alkyne. Now, what is alkene and what is alkyne? Alkene are the one in which carbon and carbon contains a double bond. Here, what do we see? Carbon and carbon contain double bond, while in alkyne, we see that carbon and carbon contain triple bond. So, these are unsaturated. Unsaturated are the ones that are containing double bond as well as triple bond. But when I am going to talk about saturated ones, that these are those which have a single bond in between them. Clear? So this was all about open chain compounds. Now when I talk about closed chain compounds, where we observe a ring-like structure, it is further classified into homocyclic and heterocyclic. What do you mean by homocyclic and heterocyclic? Basically, homocyclic refers to those when we observe same, element, same atom as seen. But heterocyclic is the one when we observe another atom other than carbon. When other atom is present other than carbon, for example, nitrogen, oxygen, right? So homocyclic, that means same atoms are present. But when I talk about heterocyclic, other than carbon also, carbon is there, no doubt it is there, but also other than carbon, one or two atoms are also present. Okay, kindly cut the word one here, okay? Other than carbon, any atom are also present. Now these atoms can be oxygen, can be fluorine, like this. Okay, if I talk about one of the examples, this is one of the example. If you see here, it is again a bond line notation, and if I represent carbon, this is carbon, 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 and here other than carbon, oxygen is also present, right? So this is a kind of heterocyclic. But when I talk about homocyclic, students, I would say a basic simple example is this. Now, according to mathematics, please don't say it is a square. No, it is not a square. Further, we are going to see and going to name this compound also. Okay, so here what do we observe? We observe all 4 atoms are carbon, so that means it is same atom, that means it is homocyclic. Now when I talk about the further classification of homocyclic, it is further classified into aromatic and alicyclic. Now aromatic are further classified into benzenoid and non-benzenoid. This we are going to study in detail in GOC portion also, so don't get worried. Now I have given you a basic classification of organic compounds which you require. The most important thing that you need to know here is, first of all, the open chain compounds and their classification. The second most thing is the closed chain compound. That's it for this lecture. Now when we'll move forward towards our next lectures, we will understand what is aromaticity, what are benzenoid compounds, what are non-benzenoid compounds. We are going to study all of these in detail, so don't worry. Right now, students, moving forward, this was a little bit theoretical portion, but now the interesting portion is going to start. First of all, we have seen what is organic chemistry, what is the classification of organic compounds, and now we are going to represent the organic compounds. How we are going to represent the organic compounds? Basically, organic compounds can be represented by 4 ways. The first method, I would say, is molecular formula. Now, what do you mean by molecular formula? If I talk about a certain example, see, basically what are alkanes? Let us take an example of alkanes. You know, also mention here, alkanes are the one that are saturated, which contains carbon-carbon single bond. They have a molecular formula CnH2n plus 2. Okay, if I talk about alkenes, I am covering all the basic concepts, so don't get confused. Alkenes are the one which have the molecular formula CnH2n, right? And if I talk about alkynes, basically students, what are the molecular formula for this? CnH2n minus 2. So this is the molecular formulas for alkane, alkenes and alkynes. I am putting it in a square so that you would know. Right. Now students, what I'm going to tell you, what is a molecular formula? First of all, molecular formula tells us that how many carbon atoms and how many hydrogen atoms are present in any compound. It is as simple. Clear? So what I'm saying is molecular formula, it represents total number of carbon and hydrogen atom, carbon and hydrogen atom in any compound, Now let us take an example of alkane so that you can understand. I'm taking, when n is equals to 4, that means carbons are basically 4, so I would say C4H10. Now, if you have this example, students, kindly see here. This is the very first example that I have taken here. Now, in this example, how many carbon atoms can you see? 4 carbon atoms. How many hydrogen atoms can you see? 10. So that means it is giving you information regarding the number of carbon atoms and number of hydrogen atoms. So this is the molecular formula which tells us about the number, which gives us the total information about how many carbon are there, how many hydrogen are there. It is simple. Now if I talk about condensed structural formula, if I have to represent this same compound into condensed structural formula, so how would I represent? I will just show the bonds in between the carbon atoms. That's it. Listen carefully. First of all, molecular formula is the one in which we are going to represent a carbon number and hydrogen number. Second is the condensed structural formula in which we are going to show the bonds between carbon atoms, right? So how many carbons are there? 4. How many carbons? 4. So I would say first carbon, second carbon, third carbon, fourth carbon. Right, here is the fourth carbon. Now, what is the next process? You know that basically it is an alkane molecule. How can you identify? I've given you this molecular formula. Here you know that in every of the cases, in each of the cases, you can see n value is going to be 4. So kindly put n value as a 4 and identify which of the compound it is. So you got to know that when I put n value as a 4, it satisfies the alkane because it is C4H10, right? If I'm going to put here n is equals to 4, what is it is going to come? C4H8, right? So it is not that compound. That means it is not an alkene. If I put here, then it is C4, we are going to multiply H6, right? So again, it is not going to be alkyne. So that means it is alkane. Now, if it is alkane, single bond should be present between the carbon atoms according to the classification. So we are going to represent a single bond here. Now, ma'am, what do we need to do the next thing? We need to show the hydrogen atoms. Now, students, the foremost thing that you need to remember is carbon has a valency of 4. That means it is going to make 4 bonds. Always remember that. So, if I talk about this carbon atom, initially it is making a bond with this carbon atom. That means one bond is already made. How many bonds are left? A carbon has a capacity to make 4 bonds. 1, it is already made. How many are left? 3 are left. So that 3 will be made with hydrogen in such a way. Clear? Now, if I talk about this centermost carbon, I would say one bond is shared with this carbon, another bond is shared with this carbon. 2 bonds are already built up. How many bonds are left? So I would say, ma'am, 2 bonds are made. So 2 are left because it can make total 4 bonds. That means here 2 hydrogen will come. it will be further attached with 2 hydrogens. Now coming towards this carbon atom, we need to see about this. It is making 1 bond here and 1 bond here. 2 bonds are already made. How many bond does a carbon atom need to make? 4. So 2 are left. Again here 2 hydrogen will come. Now the last carbon here, it is only a single bond it is showing with this carbon atom. How many bonds are left? 3 bonds are left. So here it will make with hydrogen. Now the very simplest thing I need you to understand is, whenever you look into a structure, don't get confused that here hydrogen is connected to carbon. No, I'm saying a big no. Here carbon is connected to carbon, and this carbon contains 2 hydrogen on it. When you're going to see the next representation, you are going to clarify this concept very clearly. Here what I'm going to tell you, that these single bond which I am showing is the bonds between the carbon atoms, not between the hydrogen carbon, hydrogen carbon, carbon carbon. No, it is between carbon carbon. Here carbon carbon, here also this carbon is attached to this carbon, here also this carbon is attached to this carbon. Just to satisfy the valency of carbon, we are here putting hydrogen. Now what were hydrocarbons? The compounds that contain carbon as well as hydrogen. Here you are saying carbon as well as hydrogen, so it is a kind of hydrocarbon. It is a kind of hydrocarbon, so it is satisfying the basic necessity condition to be an organic compound. Clear? Now students, these are the first 2 representation. Now moving forward towards the next representation, that is expanded structural formula. Now the word expanded itself says you need to expand. Clear? What you need to expand? Let us see that. We have already made the structure CH3, CH2, CH2, CH3, right? Now, how to make it in expanded? First of all, I'm going to write it. This is condensed structural formula. It is CSF. In short, I'm writing. Now, I have to make its expanded formula, right? Kindly see this. To make it expanded, I need to show all the bonds. All the bonds refers to the bonds between the carbon atoms and between the carbon and hydrogen atom. I have to show all the bonds. So first of all, I'm going to make the bonds between the carbon atoms. Basically, there are 4 carbon atoms. I would say 1, 2, 3, 4. The next thing what I need to do is I need to represent the bond of hydrogen as well. So here there are 3 hydrogen attached to this carbon. I would say I have to attach 3 hydrogen here. 1, 2 and 3. Now the next one carbon, it has 2 hydrogens with it. That means 1 hydrogen is present here, another one is present here, right? Now coming to this carbon atom, it is further attached to 2 hydrogens. So I would say 1 hydrogen, 2 hydrogen. Now if I talk about this carbon, it is attached to 3 hydrogens. So 1, 2 and 3. Now this is what? This is expanded structural formula. You need to expand the molecule. So it is also a kind of a representation of organic compounds where you need to represent all the bonds. Clear? Now the last and most important, I would say, kindly put a star over here because it is most important. Further in the upcoming questions, you are going to observe that during the IUPAC nomenclature, in most of the cases, you are going to see the bond line notation. So you need to know what is bond line notation, how to convert it into the further categories. I am again using the same formula, that is C4H10. This was our what? Molecular formula. So I am writing MF. Now, what is the condensed structural formula that I obtained from here? It was CH3, CH2, CH2, CH3. This was our condensed structural formula, right? Now to students, make a bond line notation. Very simple thing I need to do is, I need to just show my bonds with the help of a bond line. How? See. First of all, see, this is a carbon atom, this is a carbon atom. I'm going to show the bond between these two. So I'm saying this is my first carbon and it is a bond, and this is my second carbon. Try to understand. Now, let me do it a bit thick so that it is more clear to you. Okay, I'm saying that this is my first carbon atom. This is the bond. This is my second carbon atom. This is my first carbon atom. This is the bond. This is my second carbon atom. Now, between the second and third, there is also one bond. Between the second, there is also a bond. Then comes the third carbon atom. Now, again, we have done this thing. Now, the third is further attached to fourth and there is a bond between these. So now it is further attached and this is the carbon atom. Now the ends represent carbon atom. Basically this is what? This is bond line notation. I am just writing a short form for you to understand quickly. If you know, students, I open it up to show what it is actually. I'm making it here again for you to understand. I told you that each end represents a carbon atom. Now this is what it is, a carbon. 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 It is equivalent to this. But when we are not showing any of the atom, that means we are not showing any carbon, we are not showing any hydrogen, that is our bond line notation. This is exactly the bond line notation that we need to make. Just you need to keep in your mind this structure. From this structure, you need to keep in this mind that every end represents a carbon atom. Clear? Now, why I am doing this? Why I am not going in a straight line? See, students, if I go in a straight line, just see. If I go 1 carbon, 2 carbon, 3 carbon, 4 carbon, are you able to identify these? No, I am not able to identify because I am not able to see any of the ends. But here I am able to see the ends. Even why it is made in such a way, because it also keeps in its mind about the geometry of carbon. So that's why it is made like this. Now, students, this was the representation of organic compounds. So now it is more interesting to you to understand how we can show organic compounds in different ways, right? Now, students, let us proceed towards our question. Now, see, in this organic chemistry, lecture, I would say in IUPAC nomenclature, you are going to observe a lot of questions. More than 100 questions we are going to solve in this lecture. And I assure you that you are going to enjoy this lecture a lot. Okay, so see, the very first question of the 100+ question series is here in front of you, where you need to write the condensed structural formula of the following bond line notation. Now you have been given the bond line notations, but you need to make what? You need to make condensed structural formula. Now what was condensed structural formula? First of all, we need to, revise all of these representation. The very first was molecular formula, which tells us about the number of carbon and hydrogen atom. The second most was what? Condensed structural formula, which told us about what? The bonds between the carbon and carbon. That's it. And hydrogen are also written beside it. Do not forget that. Hydrogen are written beside it. But the bonds between the carbons are represented. Or if you don't represent directly, you write no CH3, CH2, CH2, CH3. That is also comfortable, so don't get confused. In some of the cases, again, I'm going to tell you here, in some of the cases, what they do, they also write it in such a way. CH3, CH2, CH2, CH3. So don't get confused. It is also kind of a condensed structural formula in which we are representing carbon, carbon, carbon. Hydrogen is just there to satisfy the carbon's valency. So don't get confused. It is the similar way, right? Now here, coming back to our question time. So as I was revising you, condensed structural formula is the one where we represent the bonds between the carbon, or we directly write carbon separately. In molecular formula, we are writing in a, together. We are writing all together. There are 4 carbon, there are 10 hydrogen, but in condensed, we are writing it individually. But when I come to expanded structural formula, what I say? I represent all the bonds between carbon and between hydrogen as well. And the last one and the most important one is the bond line notation. When I am not going to show any of the atom, I'm not going to write any of the atom, I'm just going to represent it with the help of bonds. That is bond line notation, right, students? So I would just say, before starting these questions, I would just say that knowledge basically is of no use until and unless you practice it. Okay, so if you'll practice it, that is going to be it will help you in your upcoming exams. So, okay, so now coming towards our very first question, this is the bond line notation. We need to convert it into the condensed one. That means we need to represent in the form of carbon-carbon bonds. So, I'm going to make it again. Okay. What I want you students to do, I want you all to at least try it once and then check your answers with me. I'm just making it a thick so that it is more clear to you, right? Now, students, this is given to us, we know that each end represents carbon atom. Here is one carbon atom, 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 here is one carbon atom. The very first thing we have done. The next thing that we need to do is valency of hydrogen. Valency of carbon. Each carbon has to make 4 bonds, right? So here carbon is making 1 bond with this carbon atom. How many bonds are left? 3 bonds are left. So that 3 bonds will be made up with whom? Hydrogen. Now if I talk about this carbon, it is making 1 bond here, another bond here. 2 bonds are already made. How many bonds are left? 2 bonds are left. That it is going to make it with hydrogen. Now if I talk about this carbon, what it is doing? It is making 1 bond here, another bond here. 2 bonds are already made. How many bonds are left? 2 bonds are left. So it is going to make it with whom? Hydrogen. Now comes the next carbon. It is making a bond here, making a bond here. 2 bonds are made. How many bonds are left? 2 are left. So it will make with hydrogen. And the last one is this carbon. It is only making a single bond. That means how many bonds are left? 3 bonds are left. So here will come CH3. So basically either you can do in such a way, or how you can do is, one more way to represent it is like this: CH3, CH2, CH2, CH3. Basically, one second, again CH2, then is CH3. Basically, these two are almost same. Yeah, basically these two are almost same. I would make it a bit down because I guess it won't get cut here. Okay, CH3, CH2, 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 CH3. Now this is equivalent. Either you put like this or you show like this. It is the same thing. It is the same thing, right? Now students, the next one, the second question. If I talk about the second question, first of all, what I'm going to do is, I'm going to make carbon atoms here only so that it is for you, easy for you to understand. See, let us make a bit thick here. I want you to do with me so that it is a more practice session for us, right? So see here, all the ends are represented by carbon, 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 right? Now we need to complete the valency of carbon. That means we need to show it with hydrogen atoms as well. So now let us see. This carbon is making a single bond. How many bonds are left? 3 bonds are left. This carbon is making 2 bonds. How many bonds are left? 2 are left. This carbon, now please see carefully. This carbon is making 1 bond here, another bond here, another bond here. 3 bonds are already made. How many are left? 1 is left. So single hydrogen will come. If I talk about this carbon, 1 bond here, 1 bond here. 2 bonds, that means 2 are left. That means 2 hydrogens will come. If I talk about this carbon, 1 bond is here, another one is here. How many are left? 2 are left. That means it will come with hydrogen. Now if I talk about this carbon, 1 is here, 1 is here, 2 are made, 2 are left. Then 2 hydrogens will come. If I talk about this carbon, only a single bond is made. That means 3 hydrogens will come. Now if I come across this carbon, it is making a single bond. That means how many bonds are left? 3. So that will come with hydrogen, right? If I talk about this carbon, it is making 2 bonds. How many bonds are left? Ma'am, 2 bonds are left. That means it with hydrogen it will make 2 bonds. Now if I talk about this carbon, it is making 2 bonds. How many bonds are left? 2 bonds are left. So it will make with hydrogen. If I talk about this carbon, again it is making 2 bonds, 2 are left, so it will make with hydrogen. Again this carbon comes, 1 bond is here, another one is here, another one is here. How many are left? Only a single is left because 3 bonds are made, right? So if I talk about this carbon, it is making 2 bonds, 2 are left, so 2 hydrogen will come. If I talk about this carbon, 1 bond is already made. How many are left? 3 are left, so it will come with 3 hydrogen. So this was the condensed structural formula. See how interesting it is, how beautiful it is looking, right? So see, we can represent organic compounds in so many ways, right? So students, the third question comes here. I'm going to solve the third here. Okay, now let us see the third one. This is our third one, right? Okay, first of all, what we need to do, ma'am, we need to represent all the carbons at the end position, right? So one carbon is here, another is here, 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 here. Okay, here also carbon will come. See, very interesting concept. It is also kind of end. Here also carbon will come. Here also one carbon will come, right? Because from here, one bond is moving this side, another is this side, one is up, one is down. That means 4 bonds are there. So it is quite interesting for you to understand. First of all, we need to, complete the valency of carbon. So this carbon is making a single bond. How many bonds are left? 3. So it will make with 3 hydrogens. If I talk about this carbon, it is making a single bond. How many are left? 3 are left, because a carbon needs to make 4 bonds. So how many will come? 3 will come. If I talk about this carbon, it is making a single bond. How many are left? 3 are left. So it will make with 3 hydrogens to complete its valency. If I talk about this carbon, it is making a single bond. How many are left? 3 are left. So it will make it with whom? With another carbon with hydrogen. 3 hydrogen. It is making with carbon. 3 bonds are left, so it will make with hydrogen. Now this is making a bond with carbon. How many are left? 3 are left. Now again here also the same way. Now these 2 carbons are still left. Now see carefully. This carbon is making one bond upside, one bond downside, one on the left and one on the right. How many bonds are made? 4 bonds are made. So if 4 bonds are made, that means valency is complete. So no need to attach hydrogen to these carbons. Okay, so now let us number all these questions so that you don't get confused. This was our first one. This was our first one. Okay, now this was our second one, and this is our third one, right? Okay, students, now let us proceed toward our next question. Now, what are you observing here? In the very first 3 cases, what we saw the single bond. But now what we are looking for, we are looking here the double bond cases. Don't get confused. It is more interesting than that. Now, again, I am drawing it again. It is somewhat like this. Let us make it a bit thick so that it is easy for us to understand, right? Okay, these are double bonds. First of all, each end represent a carbon atom. Each end represent a carbon atom. So one carbon is here, another is here, another is here, and the last one is here. Are you getting my point? Good. Now students, we need to satisfy the valency for each carbon atom. To satisfy the valency, this carbon atom basically is making how many bonds? Understand this. This carbon with this carbon is making 2 bonds. Clear? So how many bonds are left? 2 bonds are left. A carbon has to make 4 bonds. 2 bonds are already made. How many are left? 2 are left. So that 2 will be made with hydrogen. Clear? Now, if I talk about this carbon, clearly, please look into the structure. Observe the structure, you are going to get your answers. See here, 1 bond, 2 bond, and the third bond. 3 bonds are made, right? Now these 3 bonds are made. How many are left? 1 is left, because every carbon has to make 4 bonds. So it will make with what? Hydrogen. If I talk about this carbon, 2 bonds are in this direction and 1 bond in this direction. How many bonds are left? 1 bond is left. So it will make with hydrogen. If I talk about this carbon, it is making 2 bonds, students. How many are left? 2 are left. So here it will make with 2 hydrogens. Now look at this structure. It is so interesting concept what we have understood here in the case of double bond. We can also represent this like this. See how? One second. Okay, we can also write it in such a way. CH2 double bond CH, single bond CH, double bond CH2. Either show in this way or this way, it is the same concept. In this, I am just connecting the dots. In this, I am not connecting the dots. I am just showing the bonds between them. The concept here is same. The structures are same. Clear? Now, if I move forward towards the 5th case, students. Now look at the 5th case. What it looks like this. I hope that you are doing faster than me, because you have now got the concept, right? So now what we need to do is, we need to put the carbon atoms at the ends. Carbon, 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 carbon. Do not forget, carbons are going to come here also. Clear? Now we are going to what? We are going to complete the valency of carbon. This carbon is making a single bond. How many are left? 3 are left. These are making 2 bonds only. How many are left? One second. How many are left? 2 are left. This is making 1, 2, 3 and 4. See here, 2 bonds in this direction, 1 in this and 1 in this. 4 are already made, and a carbon is going to make 4 bonds only. That means its valency is satisfied. Now if I talk about this carbon, 1 bond is here, 1 is here, 2 are here. 4 bonds are made, so no hydrogen will come. If I talk about this carbon, 2 bonds are made. How many are left? Ma'am, 2 are left. If I talk about this carbon, 1 bond is made. How many are left? 3 are left. So this is basically the condensed structural formula for the second case, for the fifth case. Now if I talk about the sixth case, I'm going to make the sixth case here. What is the sixth case? Let us see. It is most important. Kindly put a star here. Kindly put a star here. It is important. See, what I want you to understand is you need to understand the ends of the bond. Where there is end, there is a carbon. See, here a carbon, here a carbon, but here also a carbon is present. It is also an end of these bonds, right? So how you will see this structure? Basically, you are going to see this in such a way. In such a way. That's why I am showing you structures in two different kinds, that you can also write in this way, you can also write in this way. These are the same things. Either you are going to just write carbon, carbon, and then hydrogen, or you can just show the bonds in such a way. They are the same thing. Just you need to represent how condensed structural formula looks like, right? So here, students, we need to show the hydrogen atoms. Now, to show the hydrogen atoms, all I would say, this carbon is making 3 bonds. How many bonds are left? Only a single bond is left. So hydrogen will come. Here, if I talk about this carbon, it is making 4 bonds. 1 in this direction and 3 in that direction. That means 4 bonds are already present. So there will no hydrogen come. Now, this carbon, if I talk about, is making a single bond with the carbon atom. How many bonds are left? 3 bonds are left. So that it will make with hydrogen. Clear? It was a very interesting case, students. It was a very interesting case. Kindly put a star over here also. Now, moving towards our 7th question. Okay, now let us draw this first of all. Basically, it is like this. Basically, it is like this. Now, what we are going to do is, one carbon is going to come here, one is here, another one is here, another one is here. Now, first of all, let us show it like this. Carbon, single bond carbon, triple bond carbon, single bond carbon. See. Same way, now we are going to satisfy the valency of each carbon atom. If I talk about this carbon atom, it is making a single bond with the carbon atom. How many hydrogens are left? 3 hydrogens are left. 3 bonds are left, so it will make with hydrogen. If I talk about this carbon atom, 3 bonds are made here, 1 is made here, 4. 4 are already made, so there is no need to put any of the hydrogen atom. If I talk about this carbon atom, 3 are in this direction, 1 in this direction, 4 bonds are already made, so there is no need for any hydrogen atom to come, right? Now, if I talk about this carbon atom, it is only making a single bond, so 3 hydrogens will come. So hence, if you are getting this case is very simple for you. Clear, students? Okay, now let us proceed towards the next one. Here we are getting a cyclic compounds. Cyclic compounds were the one in which the first carbon atom is attached to the last carbon atoms, right? In which we are going to observe the ring-like structures. So how to solve this question? Again, I'm going to draw it here. One second. Let us make it a bit thick so that you can understand it quite easily. Okay. Here one double bond is present. Also, it is like this, right? Now, what we need to do is we need to represent the ends with the carbon atoms. So what I'm going to do is one carbon is present here, another one is here, 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 and here. Clear? The next step is to complete the valency of each carbon atom. So what we need to do is, see here, this carbon is making a single bond. How many bonds are left? 3 bonds are left, so it will make with hydrogen. If I talk about this carbon, it is making 1 bond here, 1 bond here, 1 bond here. 3 bonds are made. How many hydrogens are left? That means how many bonds are left? 1, so it will make with hydrogen. If I talk about this carbon, 1 and 2. 2 bonds are there, 1 in this direction, 3 bonds are there total. How many bonds a carbon atom need to make? 4. So how many is left? 1 is left. If I talk about this carbon, 2 bonds in this direction and 1 bond in this direction, 3 are made. How many is left? 1 is left. If I talk about this carbon atom, 1 here, 2 here, 3 here, how many are left? 1 is left. If I talk about this carbon atom, only, 1 bond is made. How many are left? 3 are left, so it is making with hydrogen. It is quite interesting case. Okay, now let us see this case. I'm going to make it here. Okay. Okay, now this is the structure for this. First of all, each ends represent carbon atom, carbon, 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 carbon. The next thing is we need to satisfy the valency of hydrogen atom. So this carbon is making 2 bonds. How many are left? 2 are left, so it will make with hydrogen, right? Okay, if I talk about this carbon, it is making 2 bonds. How many are left? 2 are left, so it will make with hydrogen. If I talk about this carbon, it is making 2 bond. How many are left? 2 are left, so it will make with hydrogen. If I talk about these two, these are making 2 bonds. How many are left? 2 are left, so it will make with hydrogen. You will observe all of these are making 2 bonds. So how many will be attached to hydrogen? Clear? Okay. Now students, we can also represent this in such a way. CH2, single bond, 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 CH2. Here also, let us make CH2, then will come CH2, then will come CH2, right? Here will come CH2, here will come CH2, here will come CH2, in this way. So it can also look in this way. Don't get confused. You can write in both of these way. These both are correct. Clear? Now students, moving towards our next part, that is bonds. Now we have got to understand that what are the representation of organic compounds, how do we represent it. We have clearly understood. See why I'm moving from very basic, because when you are going to see the IUPAC nomenclature, you are basically going to get the bond line notations of the following compounds. So if you know how to convert bond line notation into the condensed structural formula or into the expanded structural formula, it will be easy for you to name them. But if you don't know what is bond line notation, you will get confused which structure it is, right? So that's why we have done the representation. Now, why are bonds important to you? I'm going to explain you this case also. Basically, there are two kinds of bonds that we are going to see. One, it is going to be sigma bond. Another one, it is going to be pi bond. These two bonds are we are going to observe. Now sigma bond basically is a single bond. Okay, and if I talk about the pi bond, basically it is what? It is a double bond or a triple bond. We are going to see in some of the cases. If I talk about the sigma bond, no, it is a strong bond. But if I talk about the pi bond, students, it is a weak bond, right? So now see what happens is, if I talk about head-on overlapping, it is seen in sigma bond, but in pi bond, it is sideways overlapping. So these are the very basic things that you have started in the chemical bonding. I'm not going in that depth. I'm just going to tell you what that is necessity for you to understand for organic chemistry, that you need to require to name organic compounds, just that things. So there is a table that you need to remember, everyone. Okay. Now, let us make a line first of all here. Okay, students, now look here very carefully what I'm going to show you. Okay. Now see here. Here you are going to write the numbers. That means the steric number basically. Here what you are going to see, you are going to see number of sigma bonds plus lone pair. And here you are going to see the hybridization for them. Okay. Now see, if you are going to see the number of sigma plus lone pair comes out to be 4, then the hybridization comes out to be sp3 hybridized. If the numbers comes out to be 3, the hybridization is going to be sp2. If the numbers comes out to be 2, the hybridization is going to be sp. Clear? Now let me tell you about sigma bonds and pi bonds, how we are going to see the sigma bonds to find the hybridization concept. Sigma bond is basically what? It is the first bond. First of all, it is the first bond. If I talk about this compound, carbon carbon bond, so it is the first bond, it is referred to as what? It is sigma bond. Now if I say carbon double bond carbon, now as I told you, sigma bond is the first bond, that means this first bond is sigma bond, and this second bond is what? It is pi bond. Clear? If I take one more case here, students, if I take carbon carbon triple bond, so what I will say, the very first bond is sigma bond, the second bond is what? Pi bond, and the third bond is what? pi bond. Clear? So the first bond is always the sigma bond. The second and the third bond are going to be pi bonds respectively. If I talk about carbon-carbon single bond, that is the case of alkanes. If I talk about carbon-carbon double bond, that is alkenes. If I talk about carbon-carbon triple bond, that is alkynes case. Clear, students? Right. Okay, now next what we need to understand is calculation of sigma and pi bonds. It is very simple. 10th question we are having here. We are going in a series from the very first topic to the last topic in a series of a question. So don't get confused how it is 10. 9 questions we have already done before. Now this is the 10th one. We have to find number of sigma and pi bonds here, right? So how to find? First of all, I want you all to make here expanded structural formula. First of all, make condensed structural formula, then expanded. Once you, do practice, you will directly tell the answer. But for the sake, for the first time, I want you people to first of all make condensed structural formula, then make expanded so that the question comes easier, right? Now look at here. This is our structure, right? If I talk about the structure very carefully, first of all, I'm going to show the condensed one. So here is carbon, here is carbon, 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 carbon. I hope you are making it faster now, right? Now we need to represent the hydrogen to satisfy the valency of carbon. This carbon is making only a single bond. How many are left? 3 are left, right? So it is making with hydrogen. If I talk about this carbon, it is making 2 bonds. How many are left? 2 are left. So it will make with whom? It will make with hydrogen. If I talk with this carbon, it is making total 3 bonds. How many are left? 1 is left. If I talk about this, 2 are left. If I talk about this, it is making a single bond, 3 are left. If I talk about this carbon, it is making 3 bond. How many are left? 1 are left. Here 3, here also 3. This is what? This is, students, condensed structural formula. I want you to make expanded structural formula for this. Now what was expanded structural formula? When we are representing all of the bonds between carbon and hydrogen as well. So now to show the structure, okay, how will I show this? First of all, see. First of all, I am showing just between the carbon atoms. Carbon, 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 carbon. The next thing what I'm going to do is, here is also carbon, carbon, carbon. Now I have to show all the hydrogen, students, right? Here there are 3 hydrogens. So I would say 1, 2, 3. If I talk about this carbon, it has 2 hydrogens with it. 1, 2. If I talk about this, it is having only a single hydrogen. If I talk about this, it is having 2 hydrogens. 1, 2. If I talk about this carbon, it is having 3 hydrogens. 1, 2, 3. If I talk about this carbon, it is having only a single hydrogen. If I talk about this carbon, it is having 3 hydrogens. And if I talk about this carbon, it is also having 3 hydrogens. Oh ma'am, this is so complex. No need to worry, students. Just I have made for you to understand the sigma bonds and the pi bonds. Sigma bonds are the single bonds, that is the first bonds, right? So how many sigma bonds are present here? For this we need to identify the expanded structural formula. Either you can calculate from the condensed, but if you are a beginner, I would suggest make expanded structural formula. Okay, now let us count. See, I'm going to put a tick over here. 1 bond between these two, second bond, third bond, fourth bond. All the single bonds are sigma bonds, right? 4 bonds over here. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 and 25. How many sigma bonds are present? 25. How many? 25. Okay, if I talk about pi bonds are the one that are the second bond or the third bond. Is there any second bond, double bond or triple bond seen here? Simply see single bond, double bond or triple bond. A single bond is there but no double bond or triple bond. Hence, pi bonds are 0. Okay. This is our very first question. Okay, that means the 10th question. Now, if I talk about the next one, 11th one. Okay, we can here see directly also. I will tell you how to see directly, but first of all, I want you to make, expanded structural formula. Now, let us make expanded structural formula for this case. See, this carbon is holding 3 hydrogens with it. 1, 2, 3. The next is single bond with carbon and it is having single hydrogen. Now there are 2 bonds with carbon, double bond is there. Then this is also having one with hydrogen. Another one, it is attached to carbon, which is further attached to 3 hydrogens, right? Okay. Now students, kindly tell me how many sigma bonds are there. Sigma bonds are the ones that have single bonds. Now again, I'm going to put a tick over here. Let us take a different color so that it doesn't get mixed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now students, 10 are present here, but see, first bond is sigma bond. Now this bond is sigma bond, but this bond is what? It is pi bond. So here also 11. How many sigma bonds are there? 11 bond. The very first bond is sigma, second one is pi, third one is pi. So how many sigma bonds are present over here? 11 are present over here. How many pi are present over here? Only one. Only one. So this is the next case answer. Clear? Okay. Now let us see towards the 12th question. If I move towards the 12th question, it is also quite simple. So I'm going to tell you how to see directly here. How to see directly. See. First of all, count all the single bonds. So here we know that carbon is attached with 2 hydrogen. That means 2 bonds. Right? Now first bond is sigma. We know this. Second bond is pi bond. Here also first bond is sigma. Second one is pi. Right? So 2 with hydrogen. 3 is here, 4 is here, again 2 with hydrogen, 6 is there. How many sigma bonds? 6 sigma bonds. How many pi bonds here? 1 and 2. How many pi bonds? 2 pi bonds. So you can also do this directly. And how will you do this directly? By more practice. By more practice, students. You know, now comes our next case. For the next case, you know, 13th question, I'm going to make its structure very clearly for you to understand. Now let us see if I am having more space over here. Okay, I'll make it here only. It is carbon is further attached to 4CN. Now what is CN, students? CN is our cyanide group. What is the bond here? First of all, understand the cyanide group here. What happens is carbon is attached to 4CN. That means if I say, I am going to make it here. If carbon is here, it is attached to 4CN. That means 1, 2, 3, 4. First of all, this thing. CN stands for here in this direction. Now, for the cyanide case, carbon is attached to carbon. For isocyanide, carbon is attached to nitrogen. This you are going to see further in this lecture only. So don't get confused. What are you saying, ma'am? Cyanide, isocyanide, what are these? We are going to see. Don't worry. I am saying carbon is attached to carbon. That means CN group, it is attached to CN group, 4 CN groups. So I have made 4 carbon. This is further attached to nitrogen. Now between CN, there is a triple bond like this. Like this. The very detailed structure you will be seeing in inorganic chemistry. I'm just going to find out the sigma bonds and the pi bonds. So if I talk about sigma bonds, students, over here, I would say the single bonds are the sigma ones. 1, 2, 3, 4, 5, 6, 7, 8. How many sigma bonds are there? 8. How many pi bonds are present over here? Let us see. The second bond is pi. The third bond is also pi. The second bond is pi. The third bond is also pi. The second bond is pi. The third bond is also pi. The second bond is pi. The third bond is also pi. How many pi bonds? 1, 2, 3, 4, 5, 6, 7, 8. How many pi bonds? 8 pi bonds. Clear? Okay, students. Now moving forward, what I would say you just a beautiful quote, students. I hear, I forget. I hear and I forget. I see and I remember. So see, observe properly. What I am saying is, I hear and I forget. I see and I remember. I do and I understand. So do and make it understand so that it will last forever. Right, students? And organic chemistry is the most interesting subject. So if you'll do, you will find it interesting until you do. Clear? Okay. Now students, moving towards our 14th question. We have to calculate something. What we need to calculate here, ma'am? We need to calculate number of sigma bonds. We need to calculate number of pi bonds. We need to calculate the number of sigma bonds between sp2 carbon and sp2 carbon. Why I told you hybridization? Just for this case. When does sp2 carbon comes? When the sum of sigma bonds and lone pair comes out to be 3, then it is sp2 hybridized. We are going to see in the questions, don't get confused. See the 14th question. First of all, tell the number of sigma bonds. Ma'am, what we need to do is, here bond line notation is present. Don't get confused. Kindly put the carbon over the ends. Now put the hydrogens. This is making 1 bond. How many bonds are left? 3 are left. This is making 1, 2 and 3. How many are left? 1 is left. It is making 2 bonds. How many are left? 2 are left. Now you can directly observe and tell the answer. See here. If I talk about sigma bond, the single bonds are the sigma bonds. So here, 3 with hydrogen, 2 with hydrogen 5, 1 with hydrogen 6. 6 with hydrogen and the carbon bonds 7, 8. 8 is the sigma bonds. If I talk about pi bond, here only 1 pi bond is there. Now comes the most important topic. Number of sigma bonds between two sp2 hybridized carbon atom. See, if I say this carbon, how many bonds it is making? How many sigma bonds it is making? Ma'am, 1 over here and 2 with hydrogen. How many total? Please calculate it. 1 plus 2 is 3. So for 3, what was hybridization? sp2. So it is sp2 hybridized. If I talk about this carbon atom, how many sigma bonds it is making? 1, 2 and third with hydrogen. So it is also again sp2 hybridized carbon atom. If I talk about this carbon, it is making single bond here and 3 bonds with this 4. Now for 4, what was hybridization? sp3. We need to find number of sigma bonds between sp2 and sp2. Between sp2 and sp2, how many sigma bond is there? Only 1. Only 1. Clear, students? Good. Now coming over this case, again what we need to do is we need to put the carbon atoms over here for you to understand more clearly. Over every end. Now we'll put hydrogen atoms. It is making a single bond, so 3 hydrogen will come. It is making 1, 2, 3 bonds. 1 hydrogen will come. It is also making 3 bonds. 1 is left. Hydrogen will come. It is also making like this. Now if I talk about this carbon, 1 bond here, 1 bond here, 2 bond here, 4 bonds are made. So no need to add hydrogen in this case. Now number of sigma bonds. All the single bonds are the sigma bonds, right? So now let us calculate over here. See, first of all, we are calculating the bonds between carbon and hydrogen so that, now you can make expanded form also. Why I am directly doing? So that it is easy for you. Now more and more practice will make you perfect here, right? Carbon and hydrogen bonds are also sigma bonds. Now you need to count that also. So here, 1, 2, 3, 4, 4 and 3, 7 and 8. 8 bonds with hydrogen. Now 9, 10, 11, 12, 13, 14. Clear? And is 15. How many sigma bonds? 15, ma'am. How many pi bonds you can see? 1, 2 and 3? 3, ma'am. Okay. Now comes what? The hybridization concept. We need to find the sp2 hybridized carbon atom. So to need to find the sp2 hybridized carbon atom, let us take a different color. Blue color we shall take. If I talk about this carbon, it is making 1 bond here, 1 bond here and 1 with hydrogen. We are only counting the sigma bonds, right? For hybridization, 3 bonds, it is sp2. It is also sp2. This one is also sp2. It is also sp2. I hope so you are getting it. It is also sp2. Now this, if I talk about this carbon, 1 here, 1 here, 1 here. We don't have to count the pi bonds. 3 bonds, sp2. If I talk about this carbon, it is making 1 bond here, 3 bond with hydrogen. It is sp3, so it is not sp2. Now we need to find out the bonds between, we need to calculate the sigma bonds between sp2. So 1, 2, 3, 4, 5, 6. 6. So how many sigma bonds are present between the sp2 hybridized carbon atom is 6. Now let us make this structure over here because it will be a little bit, problem for you to understand. I'm making this structure over here. This is also important. Kindly put a star over here. Why it is important, I'm also going to tell you again. See here in this structure, first of all, let us complete this. Here, double bonds are also there, right? Okay. Now, students, what I want you to understand here is that each end represents a carbon atom. What you all do you will do this way. Ma'am, this is the structure. No, it is incomplete. This is also an end. So here also carbon will come. Here also carbon will come. Here students, they do it wrong. So kindly consider each end as a carbon atom. Now we will put the hydrogen as a valency here. 3 hydrogen will come because only a single bond is made, right? Now, if I come across the internal carbons, these are making already 4-4 bonds, so no hydrogens will come. Now we need to calculate what? We need to calculate first of all the sigma bonds. Let us see the sigma bonds of the single bonds. First of all, we'll count with hydrogen atom. 3 plus 3, 6. 6 plus 3, 9. 9 plus 3, 12. 12 plus 3 is 15. 15 plus 3 is 18. Now, this bond is also sigma. 19, 20, 21, 22, 23, 24. Then 25, 26, 27, 28, 29 and 30. How many sigma bonds? 30. Now, if I talk about pi bonds, how many pi bonds are present over here, students? 1, 2 and 3, ma'am. Okay. If I talk about the number of sigma bonds between sp2 and sp2 hybridized carbon atoms, what is that? First of all, identify sp2 hybridized. All these carbons which are present outside are sp3 hybridized because they are making 4 bonds. So now let us see the internal ones. This is making 3 bonds. We don't have to count the pi bonds. This is sp2. This is also sp2. It is also sp2. It is also sp2. It is also sp2. And it is also sp2. So how many sp2 we have seen? We need to calculate the bonds between them, sigma bonds between them. So 1, 2, 3, 4, 5 and 6. How many bonds are there? 6 bonds are there. Are you getting my point? Are you feeling organic chemistry easier? A little bit, you are feeling lighter than before. The concept that in your mind was that it is tough, it is getting lighter. So when you move forward towards each and every topic, you will feel happy and you will be able to solve every question. Now moving forward to our next part, that is degree of carbon and degree of hydrogen. Students, it is also a very necessary topic for you to understand because it is the basic concept. What are the degrees of carbon and what are the degrees of hydrogen? So students, now we are doing degree of carbon. First of all, we need to understand how many degrees of carbon are observed. So basically, primary, secondary, tertiary and quaternary, these are the degree of carbons that we are going to see. So what I'm going to say is, one is primary, second is our secondary, third is tertiary and fourth is quaternary. Okay, now what is primary, secondary, tertiary, quaternary carbons? If I talk about primary carbon, let us complete it. Primary carbon. If I talk about primary carbon, it is the one when our carbon atom is further attached to one carbon atom. Kindly listen very carefully. When one carbon atom is further attached to one carbon atom, it is known as primary carbon. When one carbon atom is further attached to a single carbon atom, it is known as primary carbon atom, or we can say it as 1 degree carbon atom. Clear? Let us take one example for this case. CH3, single bond CH3. So here students, if I talk about this carbon atom, it is further attached to only a single carbon atom. So this carbon atom is our primary carbon atom or 1 degree carbon atom. 1 degree or primary carbon atom. If I talk about this carbon atom, it is also attached to only a single carbon atom. So it is 1 degree carbon atom or primary carbon atom. Now comes the next category, that is secondary carbon. Secondary carbon is the one when our carbon atom is further attached to 2 carbon atoms, right? When carbon atom is further attached to two carbon atom, is attached to 2 carbon atom. So it is basically refers to add secondary carbon atom or 2 degree carbon atom. 2 degree carbon atom or secondary. Let us take one more example for this. Now, kindly identify all of these carbons degree. So students, if I see here, if I talk about this carbon atom, it is attached to single carbon atom. So it is 1 degree carbon. If I talk about this carbon, it is attached to carbon atom on this side as well as on the another side. It is attached to 2 carbon atoms. Hence, it is what? It is 2 degree carbon atom. Right? If I talk about this carbon atom, it is attached to only a single carbon atom. So it is 1 degree carbon atom. So 2 degree carbon atom or secondary carbon atom is the one which is further attached to 2 carbon atoms. Clear? Now coming over the third definition, if I say about tertiary carbon. Tertiary carbon is the one when carbon atom is further attached to 3 carbon atoms. When carbon atom is further attached to 3 carbon atoms. 3 carbon atoms. It is known as tertiary, or we can say 3 degree. Tertiary or 3 degree. Now let us take one more example for this. CH3, CH2, CH, CH3, CH3. Kindly identify the degrees for all the carbon atom, students, here. So if I want to identify, I would say this carbon atom is attached to a single carbon atom. So it is 1 degree carbon atom. And this carbon atom is further attached to 2 carbon atoms. So it is secondary carbon atom or 2 degree carbon atom. If I talk about this carbon, here it is attached to carbon, here it is attached to carbon, here it is attached to carbon. So it is 3 degree. Students, don't get confused that carbon is attached to hydrogen. I have already explained you. If you consider this as a structure, kindly open it in expanded form, so that it will be able to understand the bonds are made between the carbon atoms, and hydrogen is there to satisfy the valency of carbon. That's it. So this is how this is tertiary carbon or 3 degree, because it is attached to 3 carbon atoms. If I talk about this carbon atom, it is further attached to only a single carbon atom. So it is 1 degree carbon. If I talk about this carbon atom, it is also attached to a single carbon atom. So here it is also 1 degree carbon atom or primary carbon atom. Now comes the very last case here of the quaternary carbon. Quaternary carbon or 4 degree carbon. It is the case when carbon atom is further attached to 4 carbon atoms. When carbon atom is attached to 4 carbon atoms. So basically it is known as quaternary carbon. Now let us take an example for this case as well. Let us take a different color, right? Okay, I'm going to make it here. Okay, now in this case, students, identify the 4 degree carbon atoms. Now this is the 4 degree carbon atom because it is further attached to the 4 carbon atoms. So this is the quaternary carbon. Rest all are 1 degree because they are attached to a single carbon atom. Clear? Hopefully it is clear to you. Hopefully all of these 4 are clear to you. Now let us put all of these in a box. Let us put it in a white box, right? Okay. And the last one is quaternary carbon. Okay, students, now what I want you to understand here is we have already got to know about the carbon atoms, primary, secondary, tertiary, and quaternary, right? Now comes the degree of hydrogen. The degree of hydrogen. The hydrogen that are attached to the primary carbons are refers to as primary hydrogen. So I would say that these hydrogen that are attached to the primary carbon are known as primary hydrogen or 1 degree hydrogen. The hydrogen that are attached to the secondary carbon are known as secondary hydrogen. The hydrogen that are attached to the tertiary carbon, this hydrogen, is known as tertiary hydrogen. Now, is there any hydrogen that is attached to the quaternary carbon? No. There is no hydrogen. Why there is no hydrogen? Because it is completing its valency. It is making bond with 4 carbon atoms. That's why it is called quaternary, and hence it has no hydrogen atom. That means 4-degree hydrogen does not exist. Clear, students? So this was degree of carbon and hydrogen. Now what we are going to do, we are going to apply it on questions. Here you need to find out 1 degree carbon, 2 degree carbon, 3 degree carbon, 4 degree carbon, 1 degree hydrogen, 2 degree hydrogen, 3 degree hydrogen. You know that 4 degree hydrogen doesn't exist, so we don't have to find that. Now we have the question number 17th here. First of all, students, what we need to do is we need to put the carbon atoms at the ends, right? Like this. Now we no need to show hydrogen atoms here. Why, ma'am? Because we just here want to identify the carbon atoms for the degree of carbon, but for the degree of hydrogen you need to show. So now let us make for hydrogen as well. Carbon here is attached to a single carbon. How many bonds are left? 3 bonds are left, so it will be made with hydrogen. If I talk about this carbon, it is making a single bond. How many bonds are left? 3 are left, so it will make with 3 hydrogens. If I talk about this carbon, it is making 3 single bonds, so 3 bonds are left, it will make with hydrogens. And here also this. Now this carbon is making 4 bonds, so no need to put any hydrogen here. Okay, first of all, if I talk about this case, 17th question, tell me how many 1 degree carbon are there. So see, this carbon is further attached to a single carbon, so it is 1 degree or primary carbon. This carbon is also further attached to a single carbon, so this is also a 1 degree carbon. If I talk about this carbon, it is also attached to a single carbon, it is also 1 degree carbon, and this is also attached to a single carbon, it is also 1 degree carbon. How many carbons are left? Only this is left. Now let us identify which carbon it is. It is attached to 1, 2, 3, 4 carbons, so it is quaternary carbon, that means 4 degree carbon. So if I say in this case, how many 1 degree carbon? Ma'am, 4. How many 2 degree carbon? Ma'am, 0. How many 3 degree carbon? Ma'am, 0. How many 4 degree carbon? 1. Right? Now if I talk about hydrogen, let us put it in a box. Okay, if I talk about hydrogen, students, what is the scenario for hydrogen? If I say here, the hydrogen that are attached to the 1 degree carbon are 1 degree hydrogen. Now these are 1 degree hydrogen. These are attached to 1 degree carbon. These are 1 degree hydrogen. These are attached to 1 degree carbon. These are 1 degree hydrogen. These are attached to 1 degree carbon. These are 1 degree hydrogen. How many 1 degree hydrogen are there? 3 plus 3 is 6. 6 plus 3 9. 9 plus 3 is 12. That means 1 degree hydrogens are 12. Other than this, any hydrogen is present? No. Clear? Okay, now let us see this case, 18th case. Here also, first of all, what we need to do is we need to mention all the carbon atoms. So here carbon, 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 carbon. Now hydrogen I'm going to put. Now you all would see your speed also is increasing in solving questions, in converting bond line notation into the condensed one, because practice will make you more perfect, right? Now this I have already done. First of all, I will put a circle over those carbons that are 1 degree, right? So if I talk about this carbon, it is attached to only a single carbon, it is 1 degree. If I talk about this carbon, it is attached to a single carbon, it is 1 degree. It is also attached to a single carbon, it is 1 degree. It is also attached to a single carbon, it is 1 degree. Okay, if I talk about this carbon, it is attached to 3 carbons, na? So here how many 1 degree carbon are there? 4. Okay, now I'm going to put with the yellow, right? This carbon is attached with 3 carbons. It is 3 degree. It is also attached with 3. It is also 3 degree. It is also 3 degree. It is also 3 degree. That means 3 degree or tertiary carbons are also 4. Right? So if I talk about 2 degree carbon here, so there is no 2 degree carbon here. There is no 4 degree carbon here. Now if I talk about hydrogen category, students, so I told you the hydrogen that are attached to the 1 degree carbon are 1 degree hydrogen. So how many 1 degree hydrogens are there? 3 plus 3 6, 6 plus 3 9, 9 plus 3 are 12. So 1 degree hydrogen are 12. If I talk about 2 degree hydrogen, so 2 degree hydrogen will not exist because 2 degree carbon is not there. So 2 degree hydrogen is not present, it is 0. Now if I talk about 3 degree hydrogen, so the hydrogen that are attached to the 3 degree carbon are 3 degree hydrogen. So I would say that 1 2 3 4, 3 degree hydrogens are 4, and you know that 4 degree hydrogen does not exist. So that was the case. Now let us see the 19th question. First of all, we need to show the carbon at all the edges, all the ends, sorry, not edges, all the ends, right? Now we need to mention the hydrogen atoms. We need to, fulfill the valency of carbons. So here CH3, 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 CH3. Now, if I take about this carbon, students, it is making 4 bonds, so no need of hydrogen. If I talk about this hydrogen, it is making 3 bonds, so 1 with hydrogen. It is also making 3 bonds, so 1 with hydrogen. Here also, it is CH3, 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 and it is making 4 bonds, so no need of hydrogen. Now, students, 1 degree carbon, I'm going to circle it out. 1 degree are the one which are further attached to one carbon only. It is attached to only one carbon. 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 It is also attached to one carbon. It is also attached to one carbon. 1 degree carbon, 1 degree carbon, 1 degree carbon. How many 1 degree carbon are present? 3 plus 3, 6, 6 plus 3 are 9. Okay, now how many 2 degree carbon are present over here? Let us take a different color here. How many 2 degree carbon are present over here? So if you see, there is no 2 degree carbon over here, so it is 0, because 2 degree carbon refers to those carbon which are further attached to 2 carbons, right? Now if I come to the third category, that is 3 degree carbon which are further attached to 3 carbon. So this is further attached to 3 carbon, this is also, and this is also. Basically there are 3 degree carbon. Okay, the next one here comes out to be our, let us take the case for the pink color. Okay, I'm taking the pink color here for 4 degree carbon. 4 degree carbon are the one which are further attached to 4 carbon. This is the one which is further attached to 4 carbon. This is the one which is further attached to the 4 carbon. This is the one which is further attached to the 4 carbon. So how many 4 degree carbons are present? 3 4 degree carbons are present over here. Now students, coming to the portion of hydrogen. If I talk about hydrogen, first of all, how many 1 degree hydrogens are present? So 1 degree hydrogens are the one that are present at 1 degree carbon. So let us count 3 plus 3, 6, 6 plus 3, 9. Okay, now again 9 plus 3, 12, 12 plus 3 is 15, 15 plus 3 is 18, 18 plus 3 is 21, 21 plus 3 is 24, 24 plus 3 is 27. So how many 1 degree hydrogen are present? 27. If I talk about 2 degree hydrogen, so if there is no 2 degree carbon, hence no 2 degree hydrogen will be present, it will be 0. Now coming towards our 3 degree hydrogen. 3 degree hydrogens are the one that are attached to the 3 degree carbons. How many are there? 1, 2, 3. Okay, now we know that 4 degree hydrogen does not exist. Clear, students? So hopefully you are enjoying this concept a lot. Now moving forward towards our next topic, that is degree of alkyl halide. Now degree of alkyl halide is just similar to degree of carbon. It depends upon the degree of carbon. Kindly consider this. Okay. Primary alkyl halide is the one. What is primary alkyl halide or 1 degree alkyl halide? It is the one which is attached to primary carbon. Which is attached to primary carbon. Secondary alkyl halide is the one which is attached to secondary carbon. Tertiary is the one which is attached to tertiary carbon, like this. If I talk about secondary alkyl halide, now halide stands for, let me clear you all these things. Halide are basically fluorine, chlorine, bromine, iodine. These are halogens. So these are halides that I'm talking about. Okay, when they are attached to the carbon that is a primary carbon, it is referred to as primary alkyl halide. When it is attached to secondary one, it is a secondary alkyl halide. When it is attached to the tertiary carbon, it is tertiary alkyl halide. Okay, so I would say secondary alkyl halide which is attached to carbon which is further attached to 2 carbon. That means which is secondary carbon. And tertiary is the same, which is further attached to 3 carbon atoms. So if I take the question 20th in front of you students, let us see in this case, this is our halogen atom chlorine. It is attached to which carbon atom? It is attached to this carbon atom. What is the degree of this carbon atom? It is further attached to one carbon atom. Its degree is 1 degree carbon. So if it is 1 degree and our halide is attached to 1 degree carbon atom, then this alkyl halide is basically a primary alkyl halide or 1 degree alkyl halide. Primary alkyl halide. Okay, now let us take us another case of 21st. Okay, now see, bromine here is attached to this carbon atom. This carbon atom is further attached to 2 carbon atom, hence this carbon is 2 degree carbon. So bromine is attached to 2 degree carbon, hence this alkyl halide is secondary or 2 degree alkyl halide, students. Hopefully, the degree of alkyl halide is clear to you. So, when you are clear with the degree of carbon, another one are connected to it. Right, students? Okay, now let us proceed towards the degree of alcohol. Alcohol is just similar to that of degree of alkyl halide. So, here we would say primary alcohol. Primary alcohol is the one in which OH group is attached to that carbon which is primary carbon, right? OH group is attached to that carbon which is primary. Now you know primary carbon, so you could easily identify. Now secondary alcohol. Secondary alcohol is the one in which OH group is attached to that carbon atom which is secondary. If I talk about tertiary, so when OH group is attached to that carbon atom which is 3 degree. Clear? Like this you can understand. So if I take the 22nd question in front of you, I have this OH group which is alcoholic group. It is attached to the carbon. I need to find the degree of this carbon. This carbon is further attached to 2 carbons. It is 2 degree carbon. Hence this alcohol is secondary alcohol. Hence this alcohol is secondary alcohol. Okay, now let us take this case. This OH group is attached to this carbon. Let us find the degree of this carbon. So if I find the degree of this carbon, it is attached to 1, 2 and 3 carbons. That means it is 3 degree carbon. So here it comes out to be tertiary alcohol. Tertiary alcohol. So you can easily find primary alcohol, secondary alcohol, tertiary alcohol, quaternary alcohol in such a way. So you need to understand the basic difference, what is degree of carbon. So with the help of that, you can find the degree of any of the cases. Right, students? Okay, now let us move towards the degree of unsaturation. Degree of unsaturation basically tells us that the compound contains double bond, triple bond or a ring. That means it is not saturated. Saturated means when there is a single bond. Unsaturated means when there is a double bond or a triple bond. So how to find out the degree of unsaturation? Basically, it represents the deficiency of H2 molecule in a given compound with respect to saturated acyclic compound. What do you mean by this definition? See, if I talk about a compound, simple compound, if I say CH3 single bond CH3, this is a compound. This is a saturated system when there is a single bond. But what I do, I just remove 2 hydrogen atoms. And what I get here is CH2 double bond CH2, right? Now, see what it is. It represents the deficiency of H2 molecule. Here there is a deficiency of H2 molecule in a given compound with respect to this saturated acyclic compound. So this is degree of unsaturation. That what is the degree of unsaturation that it converted from saturated to unsaturated system. So how to calculate degree of unsaturation? That is most important part, students. To calculate the degree of unsaturation, basically there are 2 cases, and with the help of these 2 cases we can easily identify degree of unsaturation. That means we can easily identify double bond, triple bond, or if there is any ring present. So students, for both of the cases, we see that basically case 1 tells us that when molecular formula is given, but For the cases when structural formula is given, that is the case 2. Now for both of the cases, there are a particular formulas I am going to tell you. So the very first formula that we are going to see is when molecular formula is given. So when you are given your molecular formula, then students, to calculate du, that means degree of unsaturation, what you need to do is you need to put number of carbon atoms plus 1 minus number of hydrogens atom plus number of halogen atoms minus nitrogen atoms divided by 2. Now this is the concept that you need to apply when you are given the molecular formula. But students, when you are given the structural formula, what you need to do is you need to just look up to the number of pi bonds plus rings. That's it. Now their sum will be equivalent to degree of unsaturation. That's it. Now these two basic formulas you need to keep in your mind. So I'm going to put both of these in a box. And kindly put a star over here. Okay. Okay, students. So if I talk you about when molecular formula is given to you, that means you need to see here, C refers to as number of carbon atoms, H refers to as number of hydrogen atoms, X refers to as number of halogen atoms. Halogen can be fluorine, chlorine, bromine, iodine. You can mention here X is fluorine, chlorine, bromine, iodine, all of these. And this is 1. It is not I, it is 1. Okay. And here N stands for number of nitrogen atom. Kindly consider when you are using this formula, then you need to neglect oxygen and sulfur when it is given, are neglected. And when structural formula is given to you, then you need to just calculate number of pi bonds and rings. That's it. So students, now moving forward towards our question number 24, you need to calculate degree of unsaturation, that means du. So here students, here structure is given to us. So when structure is given to us, what we need to do? We just need to see the pi bonds and ring. Is there any ring here? No, ma'am. So we can say that du here is number of pi bonds plus rings, and here rings are 0. So how many pi bonds? Only one pi bond is present here. The second bond is pi bond, right? Plus rings is 0. So degree of unsaturation comes out to be 1. Now if I come across the 25th case here, you need to find degree of unsaturation here, students. So kindly see here what happens is there is one ring here, right? How many pi bonds are there? 1, 2, 3 and 4. So 4 pi bonds we have and one ring. That means how many degree of unsaturation will be? 5. It will be 5. When I come across this structure, students, basically there are 2 rings. How many pi bonds are there? 1, 2, 3, 4 and 5. So basically degree of unsaturation here is 5 pi bonds and we have 2 rings. That means degree of unsaturation comes out to be 7. Hopefully it is clear to you. Now moving forward towards our next case, we have to calculate for this structure, students. Here again, degree of unsaturation, 1 is the ring. 1 is the ring. Another one here is 1 pi bond. So how many degree of unsaturation? It will come out to be 2. If I come across this, here it is 1 ring. How many pi bonds? It is 1, 2, 3 and 4. So degree of unsaturation is number of rings is 1 and how many pi bonds? 4 pi bonds are present. So what is degree of unsaturation? It comes out to be 5. Now coming across this, here we have, what do we have? We have here molecular formula. We have seen all the structural formulas. Now for molecular formula, what is the du? Du is carbon plus 1, then minus hydrogen plus halogen minus nitrogen by 2. This is the formula. How many carbon atoms are there? 4 carbon atoms. So I would say 4 plus 1 minus how many hydrogen atoms are there? 6 hydrogen atoms are there. Is there any halogen atom? Is there any fluorine, chlorine, bromine, iodine? No, ma'am. So 0 will come. Is there any nitrogen? No, ma'am. So 0 will come. Divided by 2. So here 4 plus 1 is 5. 5 minus 6 by 2. 6 by 2 is 3. That means 5 minus 3 is equals to 2. So here degree of unsaturation comes out to be 2. So you need to identify when you are given the structural formula, when you are given the molecular formula. That's it. Now students, come our 30th question, that is C6H6. Again we are given the molecular formula. So we need to write the formula for du, that is carbon plus 1 minus hydrogen plus halogen minus nitrogen by 2. This is the formula that we need to apply here, right? Now, for carbon, how many carbon atoms are there, ma'am? 6 carbon atoms. So 6 plus 1 minus how many hydrogens are there? Again, 6 hydrogens are there, right? Now, what we need to see is halogen atoms. There are 0 halogen atoms, 0 nitrogen atoms divided by 2. 6 plus 1 is 7. 7 minus 6 by 2. 6 by 2 is 3. So, all I would say is 7 minus 3 is equals to 4. So what is the degree of unsaturation here? It comes out to be 4, students. Okay. Now coming towards our 31st case. Let us see the 31st case, C8H8. Now for this case, du will be, du is equals to carbon plus 1 minus hydrogen plus halogen minus nitrogen by 2. Now, how many carbons? 8 carbons. 8 plus 1. How many hydrogens? Ma'am, 8 hydrogens. Is there any halogen? No. Is there any nitrogen? No. So, it is divided by 2. Now, what comes out here? 8 plus 1 is 9. 9 minus 8 by 2. 8 by 2 is 4. So, 9 minus 4 is equivalent to 5. So, what is the degree of unsaturation here? It is 5. Now comes important concept. Kindly put a star over here. It is 32nd question. Student, here what you need to understand, basically this is a cube-like structure. When you are given such structures, what you need to do is, to calculate du, you need to put a formula, number of faces minus 1. Okay. Now, how many faces does a cube have? It has 6 faces. So, du comes out to be 6 minus 1, that is 5. Clear? It is clear to you. So students, hopefully this concept is now clear to you. Now we are moving towards a very different concept, that is homologous series. What do you mean by homologous series? See, homologous series, if I want to define it, I would say that, for example, I have a lot of students in school, right? So in a school, when the students gather in playground, then we need to identify which students are of class 2nd, which are of 3rd, which are of 4th, which are of 5th, 6th, 7th. Now some of you people, what you will do is, you will measure them with height. You'll say they are small in height, so they might be in the kindergartens, or if they have a little bit of bigger height, they are in the senior block. So how will you differentiate? You will differentiate on the basis of their classes. Like all the class 2nd students comes here, all the class 3rd student, please assemble a line over here, all the class 4th student assemble a line over here. During the assembly time, we used to do these in school times, whenever there was assembly, whenever there was a prayer session, which you used to do, you used to sing hymns, right? So what happens was, students, each and every student was assigned a particular class according to its age, according to its knowledge, right? According to its age, like 1 or 2, maybe up or down year can be, but they are classified according to their ages into the classes. So when they're classified according to their ages into particular classes, similarly organic compounds can be classified into particular series, so that we could identify that these particular series have these kind of compounds. Like in the class 7th, I would say these are the students, and if I take a student of 10th class, so you can differentiate both of these students by the knowledge they have, by the classes in which they appear, by the examination which they give, right? 10th class students are giving boards while 7th are not giving boards. So you can identify, there are many ways to differentiate between both of these. Similarly, in organic chemistry, what do we observe? We see that organic compounds can be classified according to a particular formula, according to a homologous series. So that classification of compounds into different categories are homologous series. Now you are getting my point. Now let us read over here homologous series. I'm talking about, one second. Okay. Yes, students, I am talking about homologous series. Homologous series may be defined as a series of similar constituted compounds in which the members possesses the same functional group. Like I told you, the children that are studying in a particular class have particular age. They have been, assigned to give a particular examination for a particular syllabus. So they have a particular thing. Similarly, when I talk about organic compounds, the members should possess the same functional group, and have similar chemical characteristics. They must have these things. Okay, so hence they can be said that they are homologous series. They are of a particular class. The two consecutive members, if I talk of the first member and the second member, or if I talk about the second member and the third member, or if I say the third member and the fourth member, like of the two consecutive members, the two consecutive members differ in their molecular formula by CH2 group. Now they differ by what? CH2 group. Now let us take an example to explain you this thing. If I say I know alkane has an molecular formula as CnH2n plus 2. Now to make a consecutive members, I will put first of all carbon number as 1, and then I'm going to put as 2. So when I put as 1, I have a molecular formula as CH4. When I put as a 2, I have what? I have a C2H6. Now if I see these two consecutive members over here, what is the basic difference I can observe here is how many carbons are seen which are different. Here it is 1 carbon, here it is 2 carbon. 1 carbon difference is there. Here there are 2 hydrogens less than this. Then means that the difference that I observed in the consecutive series comes out to be CH2. So this is a very important point. Kindly put a star over here because it has a very high weightage for you to understand the concept of homologous series. Now what I am saying here is I am saying that the two consecutive members differ in their molecular formula by CH2 group, which I've already explained you here. Okay, now next thing come, all the members in a particular homologous series have the same general formula. Likewise, I told you all the students in a particular class have a same examination, have a same subject, have a same syllabus, right? Similarly, they have same general formula. For example, let us take an example of the alcohol family. They are taking an example of the alcohol family. Now for alcohol family, the formula is this: CnH2n plus 1 OH. Now if you'll put n is equals to 1, you are getting the first alcohol. If you put n is equals to 2, you are getting the second alcohol, the third alcohol, as so on, as it is moves on, right? So here it is a few examples of this family, alcohol family. When you are going to put C as 1, you are going to get methyl alcohol. When you are going to put n is equals to 2, you are going to get ethyl alcohol. When you're going to put 3, you are getting this, and similarly so on it moves on, right students? Now students, what do we observe here? What do we observe here is that these all belongs to a particular category. These all belong to a particular category. Kindly correct it. Here it is written wrong. Here it is written wrong. It is not right. Kindly correct it. It is wrong, right? So when you will write butyl alcohol, basically it is going to be C4H, 9OH. So kindly correct it. Here it will come C4H9OH. So all of these lies in the same category, in the same family, because they have the same molecular formula. Hence, they are a homologous series of alcohol. So now students, we are moving forward towards our next segment, that is going to be nomenclature of organic compounds. Now we have understood the homologous series, that how can we classify the organic compounds into particular groups so that they could have a particular formula, like alkanes have a particular formula, alkenes have a particular formula, alkynes have a particular formula. So that was all about homologous series. Now the most important concept that we need to study, for which we were studying the basic concepts, that is nomenclature of organic compounds. Nomenclature basically refers to as naming, So what happens is, when I was born, my mother gave me name Shaurya Grover, right? So that is the nomenclature of me, that is name of me. Similarly, I would say, if I have been provided any organic compound, how would I, give it a particular name? There are certain set of rules that we assign to give them a particular name. See, if you will say, ma'am, why there is a need, to provide a certain rules? For example, what happens is, you are giving a particular organic compound. One of the student is, naming it in a different way. One is naming in a different way, but it has a particular name, so that all over the world, wherever you go, you could recognize it with a particular name. So it is provided with a particular name. Hence, nomenclature is basically of two types. Students, what happens here is, let us see. It says that the term nomenclature means the system of naming of organic compounds. Like if you give me a particular name, that is my name, my name is Shaurya. So if you give me a particular name, so I can have two names here. Now, please listen to here what it is. There are two system of nomenclature. What are the two systems of nomenclature? One is the trivial or the common system. Another one is the IUPAC system of nomenclature. Common system are the one which, likewise, I would say that are like in a particular, I would say in a particular country or in a particular area, we would use common system. But wherever we grow, wherever we go across the country, or wherever we study organic compounds, in any city, anywhere, we use what? IUPAC nomenclature. That is the most important thing, International Union of Pure and Applied Chemistry's IUPAC system of nomenclature that defines us the basic rules that we apply to name any organic compound. First of all, what is trivial or common system? Let us understand this. In this nomenclature, the names of the organic compounds were assigned based on the source of origin. Now see, on the basis of source of the origin, how they originated, or certain properties, or on certain properties. For example, citric acid got its name from the source citrus fruit, from which it was first isolated, from which it was first derived. Formic acid was named so as it was first obtained from red ant. In Latin, ant means formica, that's why. Okay, some common names are even used today. So many common names are though difficult to keep in the mind, but there are many a times used when the IUPAC name is lengthy. What happens is, as we know, we can't memorize all the names, we can't memorize all the common names, hence IUPAC came. But when IUPAC naming is so lengthy, then we use common name to identify the compounds, right? But students, here in front of you are the some compounds that are given some names, common names or trivial names, I would say, based upon their origin. So first is CH4, which is referred to as methane, and if you see its IUPAC nomenclature, it is still methane, it is the same thing. But for the next cases, you see a very different kind of thing that is quite necessary for you to understand. All of these four are important. See, one is N-butane. N refers to what? N refers to a long chain. Butane refers to as a chain of 4 carbon atoms. Don't get confused, ma'am. How could we remember 4 carbon atoms refers to as butane? We will do one by one. Just I'm going to explain you a thing that you need to keep in your mind. N-butane refers to as the straight chain, a long chain. Okay. Now comes isobutane. What is isobutane? If I draw the structure over here, if I draw the structure over here, students, it is basically like this. This is isobutane. If I talk about N-butane, it was like this. Right? If I talk about, neopentane here, so this is neopentane. I'm going to tell you the basic difference here that you need to know is N1 is the straight one. ISO one is when there is one group attached, and new one when there is two groups attached on the over carbon atoms. So these, three are most important. I will explain you why here but is used, why here pent is used, but you need to understand N, iso, neo. N stands for long, iso stands for one group, and neo stands for two groups, right? Next comes N-propyl alcohol. Again, N stands for the long chain, so a long chain is there. Now comes the very names, common names, I would say, or trivial names that were derived from the origin. So number first is formaldehyde, that is HCHO. Then comes acetone, then comes chloroform, then comes acetic acid, then is benzene, then is anisole. It's a compound is given there, molecular formulas are provided to you. Then is aniline, then is acetophenone, and then the last one is there for you, that is ethyl, methyl, and if I would put here it as, I guess, oxygen is present in between there, ether is given to you. So students, no need to learn all these. Just what you need to do is you need to look once and you need to move to the other topic. Why? The three things that you need to keep remember is these three things, nothing else. Once you will be able to understand IUPAC naming, you will able to understand the common name as well. So proceeding towards our important topic that is important to us is IUPAC nomenclature. To understand IUPAC nomenclature, the very first concept that we need to understand is word root. The first thing that we need to understand is, the first thing that we need to understand is word root. You know, like in small classes, teacher teaches us A, B, C, D, E, F, right? So alphabets we learn in our small classes. When I come across organic chemistry, I'm going to teach you, when you are given one carbon atom, what is the word root used here? When you are given two carbon atom, what is the word root here? So you need to understand and you need to learn this in a similar way like you learned alphabetical order A, B, C, D, E. In the similar way, you need to learn this. And once you have learned this, rest of the case is very similar. Rest of the case is very easy when you are going to this a basic formula that we are going to apply for IUPAC nomenclature. So what you observe here is, when number of carbon atoms is 1, then the word root used is myth. When the number of carbon atoms is 1, you are using word root as a myth. When it is 2, you are using it. When carbon atoms are 3, you will use prop. When carbon atoms are 4, you will use but. When carbon atoms are 5, you will use pent. When carbon atoms are 6, you will use hex. When carbon atoms are 7, you will use hept. When carbon atoms are 8, you will use oct. When carbon atoms are 9, you will use non. When there are 10, you will use dec. When there are 11, you will use undec. And when there are carbon atom 12, you will use dodec. So repeat after me. When there is one carbon atom, you will give your answer there sitting on your places. When there is two carbon atoms, repeat. This is a practice for you. I will just say the carbon atoms number. You will say the answer by sitting at your place. This will be a practice session, right? When there is one carbon atom, when there is two carbon atom, when there is three carbon atom, when there is four carbon atom, when there is five carbon atom, when there is 6 carbon atom, when there is 7 carbon atom, when there is 8 carbon atom, when there is 9 carbon atom, when there is 10 carbon atom, when there is 11 carbon atom, and when there is 12 carbon atom. So hopefully once you have seen, you are looking into your notebooks, or you have kept your hand and spoken with me, then it will be helpful for you to move forward towards the next topic. Clear? You need to learn this. Kindly mention over here, learn this. Learn this. This is very, very important. Okay. Now students, moving towards the IUPAC nomenclature. First of all, here E will not come. Sorry for this mistake. Now, how to do IUPAC nomenclature? The very basic rule that you need to apply here is what? Kindly see over here. You need, one second. Before this, okay. Okay, so here, what is the rule for applying nomenclature? First of all, students, at the center, you need to write a word root. At the center, center means center of the notebook. You need to write word root. You need to write word root. Now, from the center, keep your notebook as a right hand side and the left hand side. When from the word root you will move towards the right hand side, you need to mention what? You need to mention the very first category, that is primary. That means 1 degree suffix. Primary or 1 degree suffix. Now from 1 degree suffix, move towards the right hand side and write down secondary suffix. Write down secondary suffix. Now from the word root, move towards the left hand side, write down primary prefix. Write down primary prefix. Now from the primary prefix, move towards the left hand side and write down secondary prefix. Secondary prefix. Most important rule for you to understand, my dear students. This rule you are going to apply in each and every question for the nomenclature. In each and every question. Now let us understand this individually. See here. If I talk about word root, which we have already learnt just right now, word root represents the number of carbon atoms present in a parent chain. What does it do? It represents number of carbon atom in a parent in a parent chain. Like I told you, if I have one carbon atom, it is meth. If I have two, it is ith. If I have three, it is prop. If I have four carbon atoms, it is but. Clear? So word root defines number of carbon atoms present in parent chain. Now there is a different word for you to understand here, parent. What do you mean by, ma'am, parent chain? What is a parent chain? Students, basically a parent chain is the one which has the large number of carbon atoms. It is the one which have the maximum number of carbon atoms. But when functional group arises, we need to keep functional group in the parent chain, whether it is kept as small. You are saying, ma'am, what are you doing? We are not getting it. Don't get confused. One by one, step by step, we will move forward. So what I'm going to tell you is, first thing that you need to remember is word root. That means how many carbon atoms are present in the parent chain. Parent chain for just now I am saying, remember, it is maximum. Mostly I would say it is maximum number of carbon atoms. But there are cases when the parent chain is small, and there you need to see the carbon atoms. So mostly I'm writing here, don't get confused. Okay. Now the next thing is primary suffix. What do you mean by primary suffix? See, whenever you are naming any organic compound, you have to do what? You have to write the centermost position first. That means the word root first. Then you will write the right hand side portion first. That means suffix portion first. And then after that you will write the prefix portion. So you need to move from secondary prefix towards the, secondary suffix. But for a beginner, to name any organic compound, kindly write word root, then suffix portion, then in front of word root you will write the prefix one. Okay. Now coming towards the primary suffix, it refers to as the bonds present in carbon-carbon. If carbon-carbon has single bond, it is referred to as ane, A-N-E. If carbon-carbon has double bond, it is referred to as ene. If carbon-carbon has triple bond, it is referred to as ine. Clear? Because we know that carbon-carbon single bond is alkane, double bond is alkene, triple bond is alkyne. So that is what I am saying. Primary suffix for carbon-carbon single bond is ane, A-N-E. For double bond it is ene, E-N-E. For triple bond it is ine, Y-N-E. Now when I talk about secondary suffix, it is used for senior most functional group. Senior most functional group. I'm going to explain you this in the further coming segments. Now, what is the functional group? I would say functional group basically is like alcohol, it is like ketone, aldehyde, carboxylic acid. So all of these situations you will see in the further segments. So don't get confused. It is used for senior most functional group. Now, if I come across the left hand side portion, first comes the primary or 1 degree prefix. It is referred for cyclic or acyclic ring. When there is any cyclic compound, for cyclic, what is the primary prefix you will use? Cyclo. And when there is acyclic compound, when there is no ring, you will use nothing. But when there is any cyclic compound, you will use cyclo. Clear? Now students, comes secondary prefix. It is refers to as extra group or substituent or side chain or junior most functional group or junior most functional group. Clear students? So this I'm going to explain you again in the upcoming questions, that what is secondary prefix. So this is the basic rule that you need to follow for IUPAC nomenclature, which is very important, students, which is very important. Now let us move towards our very first question. We will apply this rule over there. What is the very first question that comes here? Okay, here is question number 33. Okay, if I look to the question number 33, what I have here is CH3 single bond, CH2 single bond, CH3. First of all, identify carbon atoms and identify the chain. What is a chain? Chain is a series of carbon atoms. See here, it can be straight, it can be branched. I'm going to explain you. See, first of all, from here, if I start to number carbon atom, it can be 1. Let us take another color. Okay, it is 1, it is 2, It is 3. Now, some of the students will say, why not start numbering from this side? You can do. There is no issue in that. You can do. You can either go 1, 2, 3. But for most of the cases, you need to find out, is there any extra group attached to it, or is there any functional group attached to it? You need to identify these of the situations. Here, from any of the direction you go, you are getting the same groups, right? So, I am considering only one once, right? Now, what I have found is here, basically there are 3 carbon atoms. Basically, there are 3 carbon atoms. Let us write the formula over here. Word root. Right hand side is primary suffix. Over that is secondary suffix. Now, here it is primary prefix. Here it is secondary prefix. Now, students, to make it more clear, we have basically here 3 carbon atoms, and we have learned for word root that 3 carbon atoms word root is prop. What is the word root? Prop. So just write at the center over here, prop. Now students, first of all, we need to do the right hand side portion, that is the suffix portion. First comes primary suffix. We have already seen primary suffix stands for the bonds. Carbon, carbon, single bond, double bond, triple bond. So here what do we see? Carbon, carbon, single bond is present. So what is the primary suffix used over here? It is ane, A-N-E, ane. Now what is secondary suffix? Secondary suffix refers to as the functional group. Is there any functional group like OH, COH, a double bond O? Nothing. There is no functional group here, so no secondary suffix will be used over here. Now this portion we have covered. Let us move towards the prefix portion. Primary prefix was kept for cyclic and acyclic. It is a cyclic. Cyclic compounds are those when first carbon atom is attached to the last carbon atom. It is not a cyclic compound, ma'am. So it is an acyclic compound. Yes, it is open chain compound. It is an acyclic compound when first carbon atom is not attached to the last carbon atom. When it is attached, it is cyclic. When it is not attached, it is acyclic. So here primary suffix will also be not used. Now comes secondary suffix, that means extra group. Is there anything extra? Just you keep hand over these 3 carbons. Is there anything left over here? No. That means its name is propane. Its name is propane. So you have, named a particular organic compound. Now let us do this organic compound also. Here, what do you observe? Here, what do you observe? That, ma'am, if I number accordingly, I would say this is 1, this is 2, this is 3. Now, moving in this direction, 1, 2, 3, it is same situation. We are getting this CH3 over the second carbon atom. So, what is the word root here? First of all, this is our parent chain. See, in a series, you are going to get the parent chain. Now, this is the extra group that is attached over the second carbon atom. This is our parent chain. You can even mention here, this is our parent chain. Now, here, what is this? Now, what is this CH3? This is our extra group, I would say, or I would say the side chain that is attached over here. Now, how to do naming of this? Again, we have to use the same formula, students, over here. Word root. Word root stands for the number of carbon atoms in the parent chain. Now, the parent chain contains 3 carbon atoms, and the word root for parent chain will be prop. That's why I have mentioned you that kindly you have to see the number of carbon atoms in what? Parent chain, right? Not the side one. Now, some of the students who don't know naming, they will count 4 carbon atoms. They will write but, but it is wrong. Consider the parent chain, right? Parent chain is of maximum carbon atoms. Here it is 3 carbon atoms. Now comes primary suffix. That means we need to see the bonds. Carbon, carbon, single bond is present. So what is the primary suffix here used? Ane, A-N-E. Now, what is the secondary suffix? Is there any functional group? No, ma'am, there is no functional group, so no secondary suffix will be used. Now, we are going to write the prefix portion. What is the primary prefix over here? Primary prefix stands for cyclic and acyclic. When there is a ring present, then we use cyclo. When there is no ring, we are using nothing. So, primary prefix is also not used. Now, when I talk about secondary prefix extra group, this is CH3. Now, what is the name for CH3? See, we know that very sorry, students. We know that CH4 basically is methane, right? So, if I am going to remove one hydrogen from this, it is going to be methyl. That means whenever an alkane loses one hydrogen, it becomes alkyl. What does it becomes? See, methane is CH4, one hydrogen is removed. What it is left? CH3 and a bond. Carbon makes 4 bonds. 3 bonds are made and 1 bond is still pending. So, 1 bond it is making with this. That means it is what? It is methyl. It is present over which number? Second number. So, we need to mention the number of the carbon atom on which it is attached. It is attached on the second number. So, what we will do? 2. Now come dash. See, whenever you are writing a digit, that means the number, and then you are writing a letter, then a dash will come. Dash will come. So 2 dash. Now what is present over 2? Methyl is present over 2. So we will write methyl. Kindly consider all the alphabets all the alphabets you have to use in the small alphabetical order, not the capital ones, not the capital letters, small letters. So what is the naming for this? 2-methyl propane. That is 2-methyl propane. Now we will move forward towards the 35th question. This question is quite interesting. We need to understand the parent chain over here. To understand the parent chain over here, let us see. If I move in this direction, 1, 2, 3, 4, 5, 6, 7, I see that there are basically 7 carbon atoms over here. But I can also move in this direction. 1, 2, 3, 4, 5, 6, 7. Yes, I can move in this direction also. One method is to move in a straight direction. Another is to move in a branch direction. I'm moving in a branch direction also. So when I move in a straight direction, what do I observe? That groups are on the third, on the fifth as well. One of the student will say, ma'am, you can move in this direction also. 1, 2, 3, numbering from this side. 4, 5, 6 and 7. You can do this also. Yes, I can do this also. Which is appropriate? To understand this, we need to do the lowest sum rule. Lowest sum rule, students. What does lowest sum rule suggest us? Lowest sum rule says that whenever there are branches, kindly refer the number of the carbon atom on which the branch is there. Add them, the lowest number will be preferred. So if you see, if I move in this direction, red one direction, we are getting on the third carbon, we are getting this group, and on the fifth carbon, we are getting this group. If I move over the red portion, so if I move over the red portion, I am getting on third as well as on fifth. That comes out to be 8. That comes out to be 8. But if I go in this direction, straight chain, what I'm getting on the fifth, as well as on the third position, again, third and fifth, it comes out to be 8. That means both of these sums are 8. The branch chains are present on 8th carbon atom. So you can choose any of the path. You can choose any of the path. So what I am choosing is, I am choosing a quite different path now, because straight path you can do very easily. So what I am choosing is, I am choosing this direction. Now this pink one is my parent chain, and the red ones are the number of carbon atoms I have given. So this is my extra group, and this is my extra group. Now I know this extra group CH3 is what? Methyl. Now, when I come across 2 carbon atoms, what it will be? Ethyl. Right? Now, if I see this chain, 7 carbon atoms, for 7 carbon atoms, what is the word root? It is hept. After the word root, what do we write? At the right hand side, we write primary suffix. That means the bond between the carbon atoms. And here the bond between the carbon atoms is a single bond. That means ane will come. A-N-E. Now comes secondary suffix, that is refers to at the functional group. Is there any functional group present over here? No, there is no functional group present over here. So secondary suffix is also not there. Now we will move forward toward the prefix portion. So is there any primary prefix over there? No, ma'am, because it is an open chain compound. Now comes the secondary prefix, extra group. We have methyl and we have ethyl. According to the alphabet, we do. It starts with M, it starts with, E. According to the alphabetical order, A, B, C, D, E comes first. So we will mention this first. It is present on which carbon? Third carbon. So 3 dash. Now what is present on third? Ethyl. Now, on which number is methyl? On 5th, then dash, then 5, then methyl. Again, what I want you to understand is, alphabetical order is the preference. E comes first, that's why we are writing it first. M comes afterward, that's why we are writing it afterwards. Here, between alphabet and number, we are writing dash. Between alphabet and number, we are writing dash. So, its name is 3-ethyl 5-methyl heptane. Clear to you, students? Now, we will see the next question. So students, now comes our next question, that is question number 36. Basically, here also we need to, do nomenclature. First of all, let me clear it as IUPAC, right? So we need to do nomenclature. We have to give compounds their particular names according to the IUPAC nomenclature. Now in the 36th, first of all, what we need to find? We need to find our parent chain. So if I need to find my parent chain, what I should do? First I will move in a single direction, that is the straight direction. So here it is 1, 2, 3. 4, 5. Look, there are some cases when you are numbering, you need to remember that from the side which you are numbering the carbon atom, and if there is any branches, if there is any side chain present, so the nearest distance where does the branch lies, numbering will start from that side only. But here if I see I move in this direction, there is something on third carbon atom, and I move from this direction, then also there is something in third carbon atom. So it is equivalent. Another way to number the carbon atoms can be what? Listen to this very carefully. 1, 2, 3, 4 and 5. Look, you can do in both of the ways. In first of the case, in straight line, what you're observing, there is something present on the third carbon atom, and we need to separately, classify this. This can be. But the best way I would say is this one. Why I am saying this is the best way, students? Because lowest sum rule. What was lowest sum rule? That you need to write the numbers where the branching is arising. If I take the case of red one, okay, so I would say there is only group present on the third carbon atom. But if I say with this yellow one, if I consider this, then there are two groups which are present on, on the second carbon atom, and another one is present on the third carbon atom. Here branches are more, but in this case branches less. So here branches are more, but here branches are less. So we would consider this as our main chain. Now, if it is our main chain, we have found that, ma'am, why numbering is not starting from this direction, you are starting from this? Because if I move from this direction, then what I'm observing, fourth carbon is having this CH3 group, and third carbon is having this ethyl group, right? But when I move in this direction, I am looking that second carbon has something and third carbon has a group. So this is the best way to determine parent chain. Now, how will you remember in your examination, students? Practice will make you more perfect. Do practice, a lot of practice, and you'll be able to identify what is the longest parent chain. We can neglect it. Longest parent chain we can neglect it by when there is something branched or when functional group is present, then we will give priority to them. Okay, so students, now it is like 5 carbon atoms. First of all, what was the formula to do IUPAC? In the centermost position, you need to write word root. Now, for a word root, right hand side comes primary suffix or 1 degree suffix, and its right hand side comes secondary suffix. If I move forward from word root towards the left direction, first comes primary prefix and then comes secondary prefix. Now, students, to name this, what I should do, first of all, I have identified there are basically 5 carbon atoms present in this chain. So word root for 5 carbon atoms is going to be pent. It is going to be pent. Now, what's the next thing? If you are a beginner, if you are doing for the first time, students, after word root, write the right portion and then move towards the left hand side portion. So primary suffix refers to the bond between the carbon atoms. Hence, we find that carbon atom contains single bond between. So that means primary suffix is going to be ane, A-N-E-N. Now, what do you mean by secondary suffix? That means there is something functional group, related to functional group. Is there any functional group here? No, ma'am. There is no functional group. Hence, secondary suffix will not be seen here. Now comes prefix. If I talk about primary prefix or 1 degree prefix, it is seen in the case of cyclic compounds. For cyclic compounds, we write cyclo, but if it is a open chain compound, that means we no need to write any of the primary prefix. Now, the last thing, that is secondary prefix. That means something extra should be present. What is extra here? Here, this CH3 is extra, this CH3 is extra, and completely this is extra. Okay, if I talk about CH3, what do we call CH3 as? Methyl. This CH3 is also methyl. If I talk about CH to CH3, basically there are 2 carbons, and I know you, and I've already told you that whenever an alkene loses a hydrogen, it becomes alkyl. Similarly, ethane loses 1 hydrogen, it becomes ethyl. These are the extra group. Now, what we need to do is we need to see the alphabetical order. That means A, B, C, D, E. And for E stands our ethyl, which is present on what? Which carbon? Third carbon atom. So, first of all, we will number this. 3-ethyl. Now again dash, students, because number is going to come. Now we are going to represent these CH3. It is present on the second most carbon atom. So I would say 2, 2. Why I am writing 2 times? Because CH3 groups are twice on the second carbon. That's why we need to, give number to every group. We don't have to do like 2, then we'll write methyl. No, each and every group, number should be assigned. So here it is present on the second number. I wrote 2 comma 2. You will be thinking, ma'am, why comma came here? See, whenever you are talking about digits in alphabet, dash will come. But when you are talking about only digits, between two digits, comma will come. Now you know that basically two methyl groups are present. To represent two methyl groups, we use di word. To represent three, we use tri word. For four, we use tetra. So here two methyl groups are present. Again dash, then di, then comes methyl, and at the last it comes pentane. So what will be its nomenclature? 3-ethyl 2,2-dimethyl pentane. Let us put this in a box. Okay, students, I am going to put a star over every question so that it is easy for you that this is the answer of this question, right? Now comes our next question. This is our next question. First of all, we need to identify the parent chain. Parent chain should be longest. It is a condition. If until and unless functional groups are not present or any double bond or triple bond is not there. So we will move in such a direction. When I am moving in such a direction, what do I observe? This is first carbon, this is second carbon, this is third, this is fourth, this is fifth, and this is sixth. You will say, ma'am, start from this direction. Okay, I'll start from this direction. Kindly look. One carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. Okay, tell me in which direction does the branching comes first? If I move in this direction, I see that branching comes over the third carbon atom. But if I'm moving in this direction, what I'm observing is branching is coming on the fourth carbon atom. So, lowest sum rule, where is the branching? Lowest number should be given preference, hence green is given preference over here, and the nomenclature will done according to the green, right? So now how many atoms are there in this parent chain? This is our parent chain, my dear students. This is our parent chain, right? And here it is an extra group. This is our extra group, which is ethyl, Now what we need to do is we need to follow the same concept. First of all, we need to write the word root. So for word root, I would say how many carbon atoms are present here? 6 carbon atoms are there. So word root will become hex. Okay, then comes primary suffix, which denotes us that the carbon-carbon bonds. If there is a single bond between the carbon atoms, it is basically going to be ane. If there is double bond, it is going to be ene. If there is triple bond, it is going to be ine. So here, what do you observe? In carbon-carbon, there is basically a single bond. So I would say ane will come here. A-N-E, ane will come here. Now comes secondary suffix. That means whenever there is senior most functional group present. So there is no functional group here. Hence, secondary suffix doesn't lie here. Now comes the left-hand side portion, primary prefix. Primary prefix is applied when there is an closed chain compound. It is an open chain compound in which first carbon is not attached with the last carbon. Hence, primary prefix is also not used. Now comes the secondary prefix, which is referred to as the extra group. Extra group is ethyl and it is present on which carbon? Third carbon. So we will write the number on third carbon, then dash, ethyl will come, and then is hexane. So what its nomenclature? 3-ethyl hexane. What its name? 3-ethyl. Okay, 3-ethyl hexane. Hopefully it is clear to you very nicely. Okay, now I am moving forward, students, to our next question. So before our next question, I have one more concept. We have done the IUPAC nomenclature of alkanes when there is single bond between two carbon atoms. Now when does double bond arises? What is the situation? How do we provide it a name? So for that, again, I'm going to write, the formula that we use. At the centermost position, you are going to write word root. Now this I'm talking all about alkenes. Alkenes are the one in which carbon-carbon double bond is present. Now at the centermost position, you are writing the word root. At the right position, first of all, you are going to write primary suffix. Then you are going to write what? Secondary suffix. Now if I move from word root towards the left hand side portion, I would first write primary prefix. Then I'm going to write, students, secondary prefix. Right? Secondary prefix. Now, see, for alkenes, what is the basic difference that we observe? Here we are going to use, use for carbon, double bond carbon, ene. Rest of the story is same. For alkanes, there was a single bond, we use ane. Now, for alkenes, there is a double bond, we are going to use ene. Clear? Rest of the situations are almost same. Almost same, totally same. Okay, if I move forward towards our 38th question, we have double bond here. How do we do the numbering? See, the double bond carbon should be provided the lowest number. So if I start from this direction, it is getting 1, 2 and 3. The double bond lies between 2 and 3, but if I move from this direction, 1, 2 and 3, they are getting the lowest number. So this is the correct way. to provide carbon a number, right? Now first of all I'm going to write again my formula here so that it will help you. Word root, right? Then word root right hand side comes 1 degree suffix, its right hand side comes with 2 degree suffix. Now at the left hand side of the word root it is primary prefix, and at its left it is secondary prefix, students. Clear? So this is the basic general formula that we are applying over here. Just we need to see the change that here now ene will come because it is double bond. Now students, listen to me very carefully. In this situation, what do we observe? We observe that basically there are 3 carbon atoms. So word root is going to be what? Word root is going to be prop. For 3 we use prop. Clear? For 3 we use prop. Now primary suffix refers to as the bond. We see that double bond lies between first and second number. Now ma'am, how can we represent the number over here? There are 2 numbers, first and second carbon. So the lowest number is represented here. If the double bond lies between first and second carbon, you have to write first position. If it is present between 2 and 3, you will write 2. If it is present between 5 and 6, you will write 5. So the lowest number is being mentioned over here. Prop. Now dash will come. Then here if you see it is on the first position. So 1, then what is at 1 position? Double bond. That means double bond lies between 1 and 2. Clear? So lowest number is mentioned here, and ene refers to as the double bond. Now we have done primary suffix. We are moving towards secondary suffix. Is there any functional group present over here? No ma'am, there is no secondary suffix present over here. So secondary suffix is not used. Now I'm going to ask you about the prefix section. Primary prefix is used when there is a cyclic compound. Here there is no cyclic compound. It is open chain compound. Hence primary prefix is not obtained. Now if I talk about secondary prefix, that means extra group. Is there any extra group? No. So hence its name is prop 1 ene, or you can students directly write it as propene. Why directly I can write it as propene? Because you know the double bond lies between first and second carbon. When you are not mentioning where is the double bond, it is assumed to be present on the first carbon atom, in between the first and the second carbon atom. So you can directly write it as propene also. Now this was our first case for alkenes. Now okay, if I move forward towards this case, I have my double bond inside here. So from which direction I should provide it numbering? From this or this? If I move from this direction, I am getting double bond on second, third and fourth between these 2 carbons. And if I move in this direction, I am getting between first and second only. So that's the lowest, you know, position that is being provided to the double bond. So here it is 1, 2, 3 and 4. Now again word root for 4 carbon atoms, it is going to be bute. It is going to be bute. Now students, you know, you can write here buta also. Kindly mention it. So primary, because you know we are writing butane, butene, butine in such a way. I'm going to explain you one by one. See, word root we have already written. Then comes a primary suffix. It is referred to as the bond between the carbon atoms, and you know that there is double bond present at both the position, in between 1 and 2, in between 2 and 3. So how we will write it? Dash will come here. It is present on the first carbon. Then it is present on which carbon? See, I am writing the lowest number. 1 and 2 lowest number is 1. 2 and 3 lowest number is 2. 1, 2, then comes dash. Now for 2 double bonds, we are again going to use di. We are going to use di. Now for double bond, what do we use as a primary suffix? We use ene. Clear? We use ene. Now students, listen to me very carefully. Is there any prefix present over here? No ma'am, there is no prefix present over here. Hence its nomenclature comes out to be buta 1,2-diene, or bute 1,2-diene is also correct. Clear students? Now let us move forward towards our next case. Moving towards the next case is also the IUPAC nomenclature of alkenes. Okay, now here you can see again the double bond. What you need to do is numbering 1, 2, 3, 4. If I move in this direction, on the same carbon atoms there are double bonds, so you can move in any of the directions. I'm again writing the formula here. Word root should be present at the center, then comes out to be primary suffix, then comes out to be secondary suffix. If I talk about prefix section, I would say on the left side there is primary prefix, and on its left it is secondary prefix. Okay, now here if I see how many carbon atoms are there? 4. For 4 carbon atoms, what is the word root? Bute. Okay, buta. And primary suffix is basically the bond between the carbon atoms. Here is double bond. It is lying between 1 and 2 and 3 and 4. So for the lowest number, what it is going to be? 1, 3. Lowest numbers are being mentioned. Now there are 2. So di-ene. Clear? Now students, is there any prefix present over here? So no, there is no prefix present over there, so its name will be this. Clear? Okay, now let us see the next question, that is our 41st question, 41 question. Here we see double bond over here and here. In which direction should I provide numbering, from this or this? See ma'am, first and second carbon from both the directions are having double bond, but from here we are getting branch at the second carbon, but from here we are getting branch at the third carbon. So this way is preferred, 1, 2, 3 and 4. So this is our what? This is our parent chain. Now this is our what? Parent chain, my dear students. If it is a parent chain, then how we will, do nomenclature for 4 carbon atoms? What is the word root? It is but. Again, it is but, right? Now it is buta. Then I'm going to write primary suffix refers to as the bond between the carbons. Here are 2 double bond between 1 and 2 and 3 and 4. So I'm going to write 1, 3. 2 bonds are there, di. Then comes ene. Now students, is there any extra group present over here? Yes, CH3. It is a methyl group which is present over the second carbon atom. So 2 methyl buta 1, 3 diene. Clear? Okay. Now let us move towards our next question over here. Okay. I am writing all the answers with a star mark. Okay. Now comes this question. Kindly observe this question very nicely. See what we are going to do over here. We know that all the bond line notation comes out to be in such a situation. Here carbon is present. Here are 2 chlorines. Here is 1 iodine and here is CH2, CH3. So how we will provide its number? See, if I move in this direction, here I can see chlorine are present. Here I can see iodine is present. So first preference to this, second to this, third to this, fourth to this. I can move in such a direction to obtain my parent chain, right? So again for 4 carbon atoms, it is word root is buta. Then comes out what? Then comes out primary suffix, which tells us the bond between the carbon atoms. It is double bond. It is present over the first carbon. So I would say 1 ene. Now students, come secondary suffix, which refers to as the functional group. There is no such functional group. These are extra groups. These are chlorine, so it is refers to as chloro. Iodine is refers to as ido. Now if I talk about a prefix portion, first of all, let me tell you, in the primary prefix, it is used for closed chain compounds, so it is not valid over here. If I talk about secondary prefix, I have Cl with me, I have this Cl with me, I have iodine with me, which are not being mentioned in any of the cases. Chlorine is referred to as chloro for prefix and iodine is refers to as ido. Now chlorine is present over the first carbon and iodine is present over the second carbon. But alphabetically chlorine comes first, so we are going to mention chlorine first. It is present on first. 2 chlorines are present, so I am going to write 1, 1. Why? Because each and everything should be mentioned where it is present. Then comes dash, 2 chlorines are there, then di word will come, di chloro. Then again dash, on iodine is present on the second carbon, it will come ido. Okay, now what is the nomenclature for this? 1, 1 dichloro, 2 ido buta, 1 ene. Clear students? Or you can directly write butene. Or you can directly use here butene. Now students, moving forwards toward our next question. That is question number 43. It is going to be IUPAC nomenclature of alkynes. So students, for the case of IUPAC nomenclature of alkynes, now what is the basic difference from alkenes and alkanes? The basic difference is that it contains triple bond with it, right? So all I would say is here we are going to see what? We are going to see carbon triple bond carbon over here. And now for carbon triple bond carbon, what is the primary suffix used, students? For primary suffix we use yne, Y-N-E. Clear students? Now students, rest of the situation is same, rest of the formula is same. Let us write the formula also. It is word root at the centermost position. On its right hand side it is primary suffix. On its right hand side it is secondary suffix. Now on its left hand side it is primary prefix, and on its left hand side it is secondary prefix, right? Now students, I have already told you that some of the structures are going to come in the form of bond line notation. That's why I did that topic first, representation of organic compounds. Now you could identify how it is C, 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 C in such a situation. Now students, I can also write it in this way: carbon, single bond carbon, triple bond carbon, single bond carbon, right? You can fulfill the valency of carbon, that's up to you. I'm just telling you the nomenclature. So if I number this 1, 2, 3, 4. Now for 4 again we use word root as but, right students? Now see what happens is the the triple bond comes between second and third carbon atom. So I would say buta 2-ine. Buta 2-ine will come over here. Clear, students? Okay, if I move forward towards this case, what I'm getting here is I'm getting this long chain over here. I'm getting this long chain over here. So I will number these carbons. See, if I move from this direction, triple bond is seen at a farmost position, but from this direction it is closed. So numbering will be provided 1, 2, 3, 4, 5, 6, 7, and 8. Clear, students? Now for 8 carbon atoms, the word root is oct. Right, primary suffix refers to as the bond between them. Here we can see the triple bond between second and third and 5 and 6. So we will write the lowest number. It is 2, 5. Then 2 triple bonds are there. So di-ine. Right, now comes what? Secondary suffix. That refers to as what? It refers to functional group. So we are not going to use it here. There is no functional group. Now comes the prefix portion. If I talk about prefix portion, there is no primary prefix because it is open chain compound. If I talk about secondary prefix, there is no such extra group present over here. So its name is this. Clear? This is the answer. Students, one more case I'm going to explain you in this only. This is the answer for this. This is the answer for this. If you are provided with a question comes CH3, CH2, C, double bond C here, right? And you can complete the valency here, CH will come, right? Again, it is like CH, CH2, C, triple bond C, CH3. If I have this case, this is answer of this case, don't get confused. If I have this case when there is double bond also present, when there is triple bond also present, then how we will do the numbering? See, first of all, from both the directions, look into the situation that if they are getting equivalent position, then double bond is preferred over triple bond. Kindly consider this. And if they are not present equally from both of the directions, then we can do according to the double bond or triple bond which is very close, which covers very less distance, is provided the lowest number. So from here I can see triple bond is close here, so I will say 1, 2, 3, 4, 5, 6, 7 and 8. Again, students, for 8 atoms we are going to write what? We are going to write oct. For 8 we are going to write oct. Now what does the next situation comes? The primary suffix. Now here, students, see, double bond is present over the 5th and 6th and triple bond is present over the 2nd or 3rd. So first we will mention this because from this direction we are getting this triple bond, right? So if I will say 5-ene, then comes a single, then comes 2-ine. Students, kindly note, after ene is coming, so this en is only referred here. ene will not come like this. Clear? Now students, is there any prefix preferred over here? No prefix. So its name will be oct 5-ene 2-ine. Clear? Okay. Now let us move towards our next case, students. Next case is question number 45. Again, we are going to, represent carbon atoms. It is 1st, 2nd, 3rd, 4th and 5th. Now for 5 carbon atoms, what is the word root? It is, for 5, it is pent. Now students, you know that there is primary suffix which contains bond. Here triple bond is present in between 1st and 2nd and 4th and 5th. So 1st and the lowest number between 4th and 5th is 4. Again dash, then di will come because 2 triple bonds are present, and for triple bond we use ine. Clear? Now students, we will move towards the prefix portion. Primary prefix is the one when there is a cyclic chain present over here. There is no cyclic change. Kindly write penta over here. Okay, penta will come over here. Now the next thing what I am going to tell you is here CH3 is present on which carbon atom? 3rd. So secondary suffix is going to be 3-methyl penta 1,4-di-ine. Clear? Now if I move forward towards this question, let us put it in a box so that you can identify these are the answers. Okay, now if I talk about this case, see, if I move in this direction, what I'm getting double bond at the first position. So I will move from this direction 1, 2, 3, 4, 5, 6. This is my what? This is my parent chain for now. This is my parent chain. What are the extra groups present over here? This is the extra group, this is the extra group, and this is the extra group. This extra group contains 1 carbon, so it is methyl. It is also what? It is also methyl. Here it contains 2 carbon atoms, so it is ethyl. Right, students? Now if I want to name this, I want to provide it a nomenclature. So I would say there are basically 6 carbon atoms, so we are going to use hex here. then what does come? It comes the double bond. It is present over the first and second carbon. So it will come hex 1-ene, or you can directly write hexene. You can directly write hexene. Why I am saying you can directly write hexene? Because it is present over the first and, first and second carbon atom. Let me see one more thing we have forgotten here. We have not done numbering correct. 1, 2, 3, 4, 5, 6, and this is going to be your 7th. Basically, there are 7 carbon atoms over here. Sorry, students, we are going to correct it just right now. For 7 carbon atoms, we are going to use hept. We are going to use hept. Clear? Now, what comes is, it comes like the double bond. That is the primary suffix. It is present over the first and second carbon atom. So, we can directly write heptene over here. Now, if I talk about prefix portion, prefix, if I say there is a CH3 group present over second carbon atom and fourth carbon atom, which is methyl, and on the fourth as well as there is an ethyl group. So according to alphabet, E comes first, so we are going to represent it. It is present over the fourth carbon atom, so 4-ethyl. I'm just going to erase it so that it gets complete over here. Then we are going to represent the CH3 group, that is the methyl group. It is present on the second and fourth. So 2, 4, again 2 are present, so di will come, methyl, then comes heptene. Clear, students? This is the nomenclature for this case. It is 4-ethyl 2,4-dimethyl heptene. Okay, and sometimes what happens, students, during the nomenclature, some of you will forget that double bond we need to use this primary suffix, or we need to identify extra group. So don't get confused. Whenever you are doing a mistake, that means mistakes are proof that you are trying your best. And when you are trying, students, you are learning something from that situation. You know, mistakes are proof that you are practicing trying questions again and again. So whenever you are trying the questions, when you fail first time, don't get disappointed. When you fail for the second time, don't get disappointed. Just show yourself, tell yourself that I can do, I have this ability, that I can conquer any of the situations, any of the questions. Then go back to your notebook, revise all the concept and use and apply it on the questions. And see, when you are confident, you are able to solve each and every question. Okay, so learn with practice, that so that we cannot forget the things. Clear? Now, students, moving forward towards the next question, that is 47. Now we are going to do IUPAC nomenclature of cyclo compounds. Now, cyclo compounds are those compounds which what we see, first carbon is attached to the last carbon atom. And you know what is the basic formula is? The basic formula is word root at the centermost position. Then comes primary suffix. Then comes secondary suffix. If I talk about prefix portion, first of all comes primary prefix. Before that comes secondary prefix. So the basic new thing that we are going to use in cyclo compounds is, here now for primary prefix we are going to use cyclo wherever we are finding a cyclic ring. The rest of the situation is same. Now let us do this question. Here we can see basically there are 4 carbon atoms. For 4 carbon atoms the word root is what? Bute. Right? Now primary suffix, that denotes the bond between the carbon atom. Here there is single bond, so ane will come. Is there any secondary suffix? No, there is no functional group. Now moving forward toward the primary prefix, it is a cyclic compound, yes. So before word root, what will it come? It will come cyclo, which represents that it is a cyclic compound. Is there any secondary prefix? No, ma'am, there is no secondary prefix because there is no extra group. So its answer is cyclobutane. Its answer is cyclobutane. Now moving towards our next case, again we will show the carbon atoms like this. Clear? Now let us first of all count carbon atoms for the word root. If I'm starting from this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbon atoms are present over here. For 10 carbon atoms, what do we use word root? We use dec. We use dec. Now what is primary suffix? It is refers to at the bond between the carbon atoms, and we know that there is a single bond present between the carbon atoms. So for single bond, ane will come. Right? Now comes secondary suffix, that means functional group. There is no functional group present over here. If I talk about primary prefix, students, primary prefix is the one that shows us that the compound is cyclic or not. So here it is cyclic, so cyclo will come in front of the word root. Now if I talk about secondary prefix, is there any secondary prefix or extra group? No, ma'am, there is no extra group. So its name will be cyclodecane. Cyclodecane. You can again count 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 carbon atoms. Clear? Okay. Now moving forward towards our next case, that is the 49th question. So if I say here, this is This is my carbon, this is carbon atom, this is carbon atom, this is carbon atom, right? So now what is the parent chain here? Parent chain is this. This is our parent chain, you know. This is our parent chain. If I talk about this carbon, it is our extra group. Right? Now, according to the formula, what is our formula? Word root. At the right hand side, it is primary suffix. At its right hand side, it is secondary suffix. When I move towards the left hand side, first comes primary prefix, then comes secondary prefix. Okay, now let us do. For the main chain carbon atom, there are basically 3 carbons and we will use word root for 3 as prop. Now primary suffix is the bond present between the carbon atoms, and here single bond is present, so we are going to use ane over here. Is there any functional group? No. Hence secondary suffix will not be applied. Now if I come across the prefix portion, what is primary prefix? If it is a cyclic ring, yes, it is a cyclic ring, so we will use cyclo over here. Now comes secondary prefix, extra group. This methyl, one carbon is methyl. If you'll fulfill the valency of this, it will be CH3, right? It is methyl group. It is present over which carbon atom? First carbon atom. Let it be first, this second and third. Why first? Because it is attached to something extra group. So here what it will come? 1-methyl cyclopropane. 1-methyl cyclopropane. Clear? This is the answer for this particular question. If I move forward towards our 50th question. So see, for this 50th question, again, we are showing the carbon atoms in such a situation, right? Again, we have what? We have this as our parent chain. This is our parent chain. So students, we know that word root for parent chain for 3 carbon atoms, it is again prop. There is single bond present between them, so I could say primary suffix is going to be ane. If I talk about secondary suffix, it refers to as the functional group. There is no functional group, so no secondary suffix is obtained here. If I move forward to the prefix portion, primary prefix is the one that is if cyclic compound is there or not. Here it is cyclic, so cyclo will come over here. Now if I talk about secondary prefix, students, secondary prefix is something extra. Now what you can observe over here, there is one CH3, another CH3. 2 methyl groups are present over the first carbon atom. So how we will represent it? 1, 1, because we need to mention there are 2 methyls. So I would say di will come, then comes methyl, then comes cyclopropane. So its name is going to be 1, 1 dimethyl cyclopropane. So students, I hope so that you are liking this lecture a lot. I want all of the students, right? If you are practicing with it with me, kindly do one favor. Whenever you are doing a question, stop the video, do the question first, then check with me and give yourself marks. We are not going to do marks for one question. You are going to allot yourself as 4 marks. We are just generally practicing questions, so that at the end of this lecture, write your marks in the comment section so that I could see how many of you have attempted and what's your score. Okay, so we are going to learn a lot of situations today, a lot of cases today, and we are going to name them. Because, you know, we are learning today for a better tomorrow, right? We are learning today for a better tomorrow. So learn very nicely. Listen to me very nicely. Observe very carefully. Okay, students? So you will give yourself +1 marks for every correct answer. There's no negative marking. I'm just seeing that how many students secure or how many students do the correct questions. I want to know that you are trying with me. There are basically more than 100 questions, right, students? For those more than 100 questions, you need to calculate marks, and at the end of the lecture, you need to write in the comment section with your name. With your name. I will definitely like it. I will see that my students are working really hard on a particular topic, right? Okay. So now we will move forward towards our next case, students. That is going to be 51st. See, 51 here again we are going to write carbon. Carbon, carbon, carbon. Now this is also carbon, this is also carbon, this is also carbon. Here you are getting me. Here what is the new thing that we are observing? See, this ring contains 3 carbon atoms, and if I talk about the extra here over here, this is also a chain of 3 carbon atoms, but it is also containing chlorine, so it is preferred as a parent chain. Now when both are there and it contains, you know, an extra group, so it is a parent chain. And if I talk about now this thing, it is what? It is our extra or our side chain. Now how to name it, students? Again, I am going to write the formula over here for you to understand easily. First of all, we are going to write word root. Then we are going to write primary suffix. Then we are going to write secondary suffix. Clear, students? If I move towards the left direction, first of all, we are writing primary prefix. Then we are going to write the secondary prefix. Now, students, listen to me very carefully. What I'm going to explain you over here, that word root is for the parent chain. These contain 3 carbon atoms, so it will come prop. Now these contain single bond, so primary suffix is ane. Is there any secondary suffix? No, there is no functional group. Now comes primary prefix. Is this parent chain a cyclic compound? No. So no cyclo will come. Don't get confused. Now comes the most important thing that you need to keep in your mind over here is this. Students, you have basically here 2 groups. You have basically here 2 groups. See, it is attached. This is first carbon, this is second carbon, this is third carbon. This first carbon is attached to this 1, 2, 3. Right? So at the first position, we are getting the cyclic chain. That means it is coming over the prefix portion. So for secondary prefix, at first position of this carbon, it is attached. Write a bracket. If you are writing a bracket, you know that this is a cyclic compound. This is a cyclic compound. So you can write cyclo, propyl, propane. So what its name is? 1-cyclopropyl propane. Clear, students? But one thing is still left over here, that is chlorine. That is chlorine over here, which we have not mentioned. We need to mention this also. So chlorine is present over the second carbon atom. So we know that chlorine starts with what? C. So it is preferred first. It will be written in front of this, right? So it will come 2-chloro, again dash will come 1-cyclopropyl propane. Clear? Clear? Okay. Now we will move forward towards our next question. Okay. Kindly put a star mark over here for this answer. Okay. Now I'm moving towards our next question. Next question is 52. Here I'm getting 2 groups. One is chlorine, another one is bromine. So which number should I provide to these compounds? See, bromine starts with B, chlorine starts with C. A, B, C, D, B comes first. So this carbon is first, this is second, this is fourth, this is fifth, this is sixth, this is seventh. This is fifth, this is sixth. Only 6 carbon atoms are present over here. So word root for 6 carbon atoms is hex. Now, the primary suffix refers to as the single bond. For single bond, we are using ane. So we will directly write ane over here. Is there any secondary suffix? No, ma'am. There is no functional group. So secondary suffix is not used. Now coming over the primary prefix. It is a cyclic compound. Yes, it is a cyclic compound. So cyclo will come. Now comes the secondary prefix, extra group. Yes, chlorine and bromine both are the extra groups. For chlorine, we are going to write chloro. For bromine, we are going to write bromo. Now alphabetically, B comes first. So we will write 1 bromo, 2 chloro, cyclohexane. This is going to be its nomenclature, students. This is going to be its nomenclature. Clear? Okay. Now let us move towards our next question. Now we are getting the question in which we see double bonds, right? We have seen the cyclic compound with single bond. Now comes for double bond. Let's make it over here a little bit thick. Okay. It is present like this, right? Now, always give double bond the lowest number. So here I would say 1, 2, 3, 4. Why 1, 2, 3, 4? Because I know that these all are carbon atoms over here, right? I know bond line notations, right? So students, for this 4 carbon atoms, what will be the word root? But. Now, what is our, primary suffix? It is for double bond, it is ene and it is present over the first and second. So we can directly write butene. Directly write, that means here it is present over in between the first and second. But whenever it is given on second and third, then you need to mention the number. Now students, if I come across the primary prefix, then it is a cyclic compound. So cyclo will come over here. And if I talk about what? Secondary prefix, so there is no extra group. So its name is going to be cyclobutene. Its name is going to be cyclobutene. Okay. Now coming towards our next part, let us make it over here again. It is somewhat like this. First of all, this is bond line notation. So all I would say here, carbon, 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 carbon is present. Now we have to provide carbons a number. So I would say the double bond should get the lowest number. It is 1, 2, 3, 4. Now students, for 4 carbon atom, what is going to be our word root? It is going to be but. Again, after that we are writing primary suffix, that is refers to as the bond between them. Here is a double bond between first and second carbon. So we can directly write butene. Clear? Secondary suffix is there or not? No, ma'am. There is no secondary suffix. Only primary suffix was there, that we wrote as ene. Right? Now comes prefix portion. What is the primary prefix over here? Cyclo, because it is a cyclic ring. Now comes the extra group that is under the category of secondary prefix. These are CH3 groups which are present over third and fourth carbon atom. So now let me write it a bit down. See, 3, 4 dash dimethyl cyclobutene. Clear, students? Why I am using di word? Because two methyl groups are present. Clear? This is the answer for this case. Now moving forward towards our next case, 55th case. Okay, this is our case. I hope so you can do it very quickly. I'm going to make it again over here. This is the situation. So you will number the carbon which contains the double bond, the lowest number. So I would say 1, 2, 3, 4, 5, 6. Clear? Now let us represent carbon atoms all over there. Carbon, 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 carbon. Clear? Now what is the word root for 6 carbon atoms? It is hex. After this comes the primary suffix that comes out to be for double bond is "ene" between first and second. So we can directly write as hexene. Now the next situation comes for the secondary suffix. There is secondary suffix? No, there is no functional group. Now we come across for what? We come across for prefix portion. Is there any primary prefix? Yes, it is a cyclic compound. So cyclo will come in front of this. Is there any secondary prefix? Yes, methyl group is present over first and second. So I would say 1, 2 dimethyl cyclohexene. This is the nomenclature for this case. Okay, students, this is the nomenclature for this case. Put a star over here. Now comes our next part. Again, I'm going to draw it a bit in such a situation. See, CL. BR. This is the situation, students. First of all, write the carbon atoms all over here. Carbon, 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 carbon. The next thing is that double bond should get the lowest number, but chlorine starts with C, bromine starts with B. So we want bromine to come the lowest number, then chlorine. So I would say this is first carbon, this is second carbon, this is third carbon, this is fourth carbon. So for 4 carbons, what we are going to write for 4 carbons, the word root is going to be but again. Now comes the bond between them, that is the primary suffix. There is a double bond here. So we will write butene over here because it is in between first and second carbon. Is there any secondary suffix present over here? No, because there is no functional group over here. Now comes to the previous portion, that is the prefix one. Primary prefix, we use cyclo for cyclic compounds. Yes, it is cyclic, so we are going to use cyclo over here. Now comes what? Now comes our secondary prefix. That means something extra. So here we are finding chloro and bromo as an extra. So first of all, we know that bromo starts with B, so we are going to write it first. So it is going to be 3 bromo, 4 chloro, 3 bromo, 4 chloro, cyclo, butene. This is going to be the nomenclature for this case. Clear, students? Put a star mark over here. I hope so. Now you're getting all of the questions, right? Okay. Now moving forward towards our next question. Again, we need to do an IUPAC nomenclature, right? Okay. For this case, students, you can see there is a double bond present outside the compound also, right? First of all, I'm making it here a bit big structure like this. Okay. Now for this case, first of all, we need to mention all the carbon atoms. Carbon, 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 carbon. Clear? Now students, this is our parent chain because it contains maximum number of carbon atoms and it contains more double bond as compared to the outside system. So all I would say is that this system basically is our extra group or side chain, I would say. And here this is our parent chain, right? This is our parent chain. So parent chain contains how many carbon atoms? It contains 6 carbon atoms. If I number them 1, 2, 3, 4, 5 and 6. For 6 carbon atoms, it comes hex. Now for primary suffix, it comes out to the bond between them. First and second contain double bond and even fourth and fifth contain. So we will write the lowest number 1, 4 di. Now for double bond we write "ene," right, students? Now it is cyclic, so we will write prefix as cyclo over here. Okay. Now students, come secondary prefix, that means extra group or side chain. This is what? Now if it is a first carbon atom, it will be second carbon atom, it will be third carbon atom. If I am going to write these carbon atom individually, what it is basically, so I would all say that these are present on the first carbon atom. It is present on the first carbon atom. It contains, it contains two carbon over here. So it is our ethene. Basically, it is our ethene molecule. So we will write ethanyl over here. Like for methane, we make it methyl. For alkane, we make it alkyl. For ethene, we will make it ethanyl. Like this. Cyclohex 1,4-diene. Clear, students? Now comes this case. See here. Carbon, 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 carbon. Now there is a triple bond case over here. For this, we know that 1, 2, 3, 4, 5, 6, 7, 8 carbons are there. Oct will come word root. Now, primary suffix is the bond between them. It contains triple bond over the first and second carbon. So we can directly write as octyne. Okay, now is there any secondary suffix over here? No, because there is no functional group. Primary prefix, yes, it is a cyclic, so cyclo will come. Secondary prefix is there? No, so its name is going to be cyclooctane. Clear, students? These were the two cases we already seen with the help of the previous structures. Now comes the 59th question. It is a kind of a very important thing that you need to know. These are bicyclo compounds, students. These are refers to as bicyclo, in which two cyclic rings are observed. It can also be represented in such a situation. In some of the books, you are going to see it like this. It is also represented like this. Now, you can do naming with the help of this also, with the help of this also. I'm going to tell you one thing, that these carbons, or I would say these carbons are the one that are, present in both of the cyclic compounds. Bicyclo refers to as two cyclic compounds. These carbons are present in both of these. So these are known as bridgehead carbon. Bridgehead carbon. Now, how to do naming? We have to move from one bridgehead carbon towards the another bridgehead carbon. Like if it is the first carbon, I have to move towards this position. So this is first carbon, second carbon, third carbon, fourth carbon. Now move this side, fifth carbon, sixth carbon, and seventh carbon. Basically, this is the, numbering for the carbon atoms. And now how to write it? First of all, we are going to write bicyclo. Then we are going to use what? Square brackets. In square brackets, we are going to write the number of carbon atoms present over the bridgehead carbons. How I am saying that? First of all, see the position. From bridgehead carbons, see the left hand side. How many carbons are there? 1 and 2? 2 carbons. In the right hand side, how many carbons are there? 5 and 6? 2 carbons. At the top of this is, how many carbon is there? Only 1. Now, you need to write in the descending order. Descending order refers to as the number which is more than less than less. 2 is more, 1 is less. 2 will come first. 2, 2, 1 in descending order. Now, how many atoms are there? Total 7 atoms. For 7 atoms, what do we write as a word root? Hept. And they have single bond, so it is refers to as heptane. Now, this is the nomenclature, and it is quite different from the cases that we are studying. First of all, you have to write bicyclo when there are 2 rings present, and you have to move from one bridgehead carbon to the another one, and you have to then count how many carbon atoms present on the left hand side, on the right hand side, on the topmost position. So you will write in the descending order. Then comes your word root and your primary suffix. Clear? Now let us apply the same concept over here. This is my carbon atom, carbon, 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 carbon. I have to move from one bridgehead carbon towards the another. I'm moving from this direction. This is my first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. Now this is seventh carbon, eighth carbon. Clear, students? Now, students, here what I am observing again, bicyclo I'm going to write. After writing bicyclo, square bracket starts. Now, from these bridgehead carbons, the left hand side, 2 carbons are present. Right hand side, 2 carbons are present. At the topmost position also 2 carbons are present. So, what is the descending order? 2, 2, 2. How many total carbons are there? 8 carbons. So, I'm going to write it as oct. And the bond between them is single bond. So, it is going to be octane. Clear, students? So this was about bicyclo compound, students. Now we have done the simple nomenclature. That means we have done the nomenclature for alkenes, alkynes, alkanes and bicyclo compounds as well as cyclic compounds. When it comes over the functional group, basically now we are going to do the nomenclature in which functional group is present. Again and again in every question I am asking you, what is the secondary suffix used over here? What is the secondary suffix used? Secondary suffix is used for the senior most functional group, and primary, secondary prefix is used for junior most functional group. I've already told you in the starting. So now we are going to see the role of both of these cases. First of all, you need to understand what are the functional groups, how are they represented, so that you'll be able to identify functional group in a particular compound. So see over here. Okay, if I talk about alkanes, this we have already done. Alkanes basically have a single bond here, and we use suffix as "ane." This we have already done. For alkenes, we use suffix as "ene." For alkynes, we use "ine." This we have already done. Now comes the next situation. For halides, students, what do we use as a prefix? Hello. Why hello? For chlorine, you are using chloro. For bromine, you are using bromo. For iodine, you are using ido. So hello is used for halides when you are writing prefix, right? As we have done in the previous cases. Now comes alcohol. For alcohol, students, alcohol functional group is OH group. Wherever you are going to find OH group, it is the alcoholic group. Now, prefix that you use for alcohol is hydroxy, and suffix that you use for alcohol is ol. Don't get confused. I'm just giving you this table. I'm going to help you out in every case. For carboxylic acid, for aldehyde, for ketone, for alcohol, we will do one by one. But just to summarize it in a page, I have given you this table. Now comes next is aldehydes. For aldehyde, it is refers to as CHO group. Now its prefix can be formyl or oxo. I'm going to tell you where is oxo used, where is formyl used in the coming segment. Then suffix, wherever we use suffix, we use al, al. Now comes over the ketones. Ketones are represented by C double bond O, and we use prefix as oxo and suffix as on. Clear? Okay, if I talk about nitriles, nitriles are basically carbon triple bond nitrogen. Okay, now for this we use prefix as cyno and suffix as nitrile. The next one is ether. Ether is basically ROR group, and for prefix we use alkoxy. And for suffix we don't use anything. There is no such case observed over here. Okay, now students, we will see another which are left. One is carboxylic acid. It is the most important. It is important. Okay, for carboxylic acid, the group is represented by COH, and prefix is used as carboxy while suffix is used as oic acid. See why I am saying prefix suffix. Whenever we are writing any compound, we are given with a basic formula. So we have to put these names now on the basic formula. Clear? I'm going to explain you how. For carboxylate ions, C double bond O negative, and for this suffix is used as O8. Now comes our next esters. For esters, it is COOR, and alkoxy carbonyl is its prefix, and suffix is O8. It is not asked much. Carboxylic acids are asked much. Aldehydes, ketones, alcohols, these are the things that are asked very much. Rest you should know, you should have knowledge. So I have written all of these over here. Acyl halides are the one which are COX. X can be fluorine, chlorine, bromine, iodine, and prefix can be used halocarbonyl, and suffix is oil halide. Next comes amine. Amine can be NH2, NH, or N. Okay, but we will use prefix as amino and suffix as amine. The next one is amide. For amide, we use CONH2, CONHR, and CONR2. Like first of all, 2 hydrogen were there. One is replaced with alkyl group. Then 2 are replaced with alkyl group, R group. For this, we use prefix as carbomyl, and for this suffix is used as amide. And the last case is nitrose, that is NO2. For this, we use prefix as nitro. So these were the functional group, students, that you need to know. Now comes our priority order or seniority order, I would say. Most important. Most important. If you know this, then there is nothing tough for you. Okay, it is seniority order. Okay, students, it is seniority order. Let me explain you how. You have to learn all of these in a sequence. Like first of all, you are talking about what? You are talking about carboxylic acid. First of all, you are talking about carboxylic acid, which is COH. For this, you have to use secondary suffix as oic acid or carboxylic acid. I will explain you how. And for this, you will use secondary prefix as carboxy. Then comes SO3H. Sulfonic acid. For this, you will use secondary suffix as again sulfonic acid only, and prefix over here is used as sulfo. Now comes the next one we have over here. This is anhydride, C double bond O, O, C double bond O. It is oic anhydride, which is used as secondary suffix, or carboxylic anhydride is used as a secondary suffix. But if I talk about secondary prefix, no senior group is present with it. Whenever it is used, it is present only alone. Then we talk about ester, C double bond O. O8 is used as a secondary suffix, and for secondary prefix we use alkoxy carbonyl. Then comes students what? C double bond O X, that is acid halide. We use oil halide for the secondary suffix, and for secondary prefix we use halocarbonyl. Now which are important that I want you to remember is these, these three. Basically the most important are the one which I am representing with 2 stars, right? This is okay, you should know, but these three are most important. Now moving to the next priority order, you need to remember this in this situation only, right? Now comes what? Now comes C double bond O NH2, that is amide. Okay, for this we use carbamyl. Now for this is our cyanide group, and for this secondary suffix is used as nitrile. Sorry, for this secondary suffix is used as nitrile, and for this secondary prefix is what? Cyano. And CHO, whenever you are seeing CHO, it is aldehyde group. For this secondary suffix is al, and for this secondary prefix is formyl or oxo. I'm going to tell you where formyl is going to be used and where oxo is going to be used. Then comes C double bond O, that means ketone, and for this we are going to write secondary suffix as on, but secondary prefix can be oxo or keto. Next comes OH, which is alcohol. For alcohol we write ol as a secondary suffix and hydroxy as a secondary prefix. Now if I talk about SH, that is thiol. Thiol we can use, thiol as secondary suffix, but for secondary prefix it is used as mercepto. Then comes NH2, which is amine as secondary suffix and amino as secondary prefix. Okay students. Now students, this was, the order that you need to remember for the functional groups, and how you will remember by more and more practice. You have to compare. Carboxylic acid is the supermost position, then comes sulfonic acid. If you'll compare with alcohol, thioalcohol, you will say alcohol gets the first position, then comes the thioalcohol. So you need to compare and you need to learn it out. Now we will apply these all conditions for the functional group nomenclature also. Now our heading is naming of important functional groups. Now we are going to do for most important functional group. The number first is going to be carboxylic acid. So now students, we are doing our first case, that is carboxylic acid. We have seen in the table, but I am going to tell you some of the functional groups which are most important for you to understand. Carboxylic acid basically is represented by COOH, or I would say it is represented like this. Clear? This is carboxylic acid group. So whenever you are going to see this or this, it is the same thing. The next thing that we need to keep in our minds is secondary prefix. What is secondary prefix used for carboxylic acid, and what is secondary suffix used for carboxylic acid? So secondary suffix, first I am telling you, it is oic acid. We use secondary suffix as oic acid or carboxylic acid. I will tell you where to use these kinds of, situation. Carboxylic acid. Now, if I talk about secondary prefix, it is carboxy. Kindly learn these for the important functional groups. Now, how to apply these in question? Question number 61 is in front of you. It is CH3COOH. Now, see, this COH carbon is also counted in the parent chain. Do notice this is also counted in the parent chain. Hence, it is 1, it is 2. So, for 2 carbon atoms, what is the word root? I'm going to write the formula again here for you. Word root. Then at the right hand side position comes primary suffix. Then comes secondary suffix. If I talk to the left hand side, it is primary prefix. And towards if its left is secondary prefix. Okay students, now if I see here for 2 carbon atom, what is the word root? Ith is the word root, right? Okay. After that, what is the primary suffix? It is the bond between the carbon atoms. Between the carbon is a single bond. So I will use ANE. Now students, come secondary suffix. As I told you, secondary suffix is used for functional group. Here our functional group is COH. Now, what is the secondary suffix? I have already told you, secondary suffix we are going to use as oic acid. When we use oic acid when our carbon is included in the parent chain. When that COH carbon is not included in the parent chain, we are going to write secondary suffix as carboxylic acid. So here COH is included in the carbon chain, so we will write oic acid. So you know that ethane ends with E and oic acid starts with O. So 2 vowels cannot come together. Kindly keep in your mind. So ethanoic acid will be there. It is ethanoic acid. Now, is there any prefix over there? No. So its name is going to be ethanoic acid. Now comes this situation. Here see. As I told you, COH group carbon can be included in the parent chain and it is given the first priority. So this is the first carbon here. This is second carbon, this is third, this is fourth. You can't move in this direction. See, if you move in the straight direction, there are 5 carbon atoms, but you know that if there is any functional group, kindly give that functional group the most priority and start numbering from that functional group. Hence now, if the parent chain is small, it will be valid, there is no issue, but functional group should be present over there. Clear? Now, for 4 carbon atoms, what is the word root? It is but. Okay, there is single bond between each carbon atom. That means primary suffix is going to be ane. Now we know that secondary suffix is basically the functional group. And here it is COH present over the first carbon. When it is present in the first carbon, it is directly written as oic acid. Again, ethane's E will be cancelled and oic acid will come. Clear? Now comes the prefix portion. Primary prefix is used when the compound is cyclic. It is not cyclic, it is open chain. So primary prefix is not used. When I talk about secondary prefix, I have this extra. This is what? This is ethyl. It is present over which carbon? Second carbon. So it will come 2-ethyl butanoic acid. 2-ethyl butanoic acid. Now I'll come over the next situation. See over here. Either I can start numbering from this or from this. It is the same thing. 1, 2, 3, 4, 5. Again, I am repeating this COH group. Carbon is also included in the parent chain. So there is a parent chain of 5 carbon atoms. Word root is written as pent. Now, primary suffix is the bond between these carbon atoms. It is a single bond, so ane will come. Now, secondary suffix is the functional group, and we know that COH group is the functional group. So, it starts with, oic acid starts with O, and E and O both are vowels. It will not come together. So, oic acid will come. But there are two, there are basically 2 functional groups, and they are at the terminal position. They are at the cornermost position. So, we can directly write pentan dioic acid, or we can write pentan dash 1,5 dioic acid. Why I am using di is preferred over here because 2 COH are present. You can directly write also this pentan dioic acid. It is the same thing. If you will mention the number, it will be best for you. But if you're not mentioning, you can directly write. The examiner knows that COH is the terminal most position carbon atom. So it will come, functional group will come at the corner. So it will be identified. Now, if I talk about primary prefix, there is no primary prefix over here because it is open chain. Then comes secondary prefix, that is CH3. It is present at the third carbon. So it is going to be 3-methyl pentan 1,5 dioic acid. Clear? Okay, now comes question number 64. Okay, now question number 64, what I have a double bond over here. So 1, 2, 3, 4, 5. Now observe very carefully. See, now this COH is not included. It is not included in the parent chain. So we will write secondary suffix as carboxylic acid. When it is included in the parent chain, we were using oic acid. So how to, mention it? There are basically how many carbon atoms? There are basically 5 carbon atoms in the parent chain. So for 5, we use pent. Double bond is present over here in the first and second. So ene will come. Now, ene E will be cancelled because there is our carboxylic acid. But we know carboxylic acid starts with C, so we can directly write it as this. Pentene, now dash for 1, 2 dicarboxylic acid. Again, I'm mentioning you can't use here oic word. Why you can't use oic? Because it is when COH is included in the parent chain, oic is used. Otherwise, it is not used. Clear? Okay. Now, students, you can even mention the double bond position. Pent 1 ene. You can write this also. It will be correct measure, or you can directly write also. Now comes any extra group. No, there is no extra group, but there is a primary prefix, that is cyclo. So you can either write it as cyclopentene 1,2 dicarboxylic acid, or you can write it as cyclopent 1-ene 1,2 dicarboxylic acid. Oic word will not come here because it is not included in the parent chain. Clear? Okay. Now comes our next case. In this case, see, I can move in this direction because I have to include COH group also. 1, 2, 3, 4, 5. For 5 carbon atoms, what is the parent chain? What is the word root? It is pent again. For single bond, it is ane, primary suffix. For secondary suffix, it is functional group. Functional group is COH and it is present on the terminal most position. So we can write, pentane 1,2 dioic acid. Clear? Pentane 1,2 dioic acid. Now, students, is there any cyclic compound? No. Secondary prefix, yes. This COH is still left. So secondary prefix for COH we have used as carboxy. It is present on the third, so it will be 3-carboxy pentane 1,2-dioic acid. Or students, what you can do over here is this. One thing I have done wrong here. Here 5 will come. 1,5-dioic acid, because at the first and the fifth carbon most. Or you can write in different way also, students. You can write how you can take this as a parent chain and these are your extra groups. You can write in this way also. It is also the similar pattern. Now moving forward towards the general formula. What it is basically the general formula when 2 carboxylic acids are present. So we are going to use N value over here and we are going to write all of these. It is the common names and you need to write the IUPAC name over here. So first of all is when N value is equals to 0, it comes out to be COH. You will put N value over 0, so COH will come. It is oxalic acid. When N value is 1 here, so it will come COH, CH2, COH. It comes out to be malonic acid. If I talk about N value is equals to 2, then it comes out to be COH, CH2 twice COH. It is succinic acid. If I say N is equals to 3, here 3 will come. It is referred to as glutaric acid. N is equals to 4 is adipic acid, 5 is pimelic acid and 6 is subric acid. Now students, to remember these names, there is a shortcut I have given to you. These are the common names: OMS, GPS. O stands for oxalic acid, M stands for malonic acid, S stands for succinic acid, G stands for glutaric acid, A stands for adipic, P for pimelic and S for subric acid. Just to learn. But I would tell you, we need only IUPAC nomenclature. Just for your clarification, I have also provided you the common names. Now what will be the IUPAC nomenclature? Let us do this. So students, for the very first case, we see COH and COH. We know 2 carbon atoms are present. For 2 carbon atoms, what is the word root? For 2 carbon atoms, ma'am, it is ith. Then what is the primary suffix? Primary suffix is single bond between the carbon atoms, ethane. Now, the next is secondary suffix. Secondary suffix refers to as functional group. Yes, functional group is present. So, oic acid will come because it is counted in the parent chain. But E and O can't come together, students. They can't come together. So, we will cancel this E. Now, we know that 2 carboxylic acid are present. So, we can write dioic acid. It is understandable that if 2 carboxylic acid are present, they are present at the corners, right? Now, for the next case, basically there are 3 carbon atoms in the parent chain. So, I am going to write it as propan dioic acid. Similarly, when I see there are how many carbon atoms? 2 here, 3, 4 carbon atoms. Then butane dioic acid. If I see the next case, after butane, what is going to come? Pentane dioic acid for 5 carbon atoms. Now for 6, it is hexane dioic acid. For 7, I would say heptane dioic acid. And for 8, it is going to be octane dioic acid. So these are the IUPAC. So with the help of the formula, you can easily write all of these, right? This was question number 66 question. Now we are moving forward towards the question 67. We are going to do the naming of sulfonic acid now, students. It is much easier as you have done, carboxylic acid. Similar way, the secondary prefix that we use for sulfonic acid is sulfo. It is sulfo. If I talk about secondary suffix, then we use sulfonic as it is. Sorry students, I guess there is some issue in this. I am writing it again. Secondary suffix as sulfonic acid. Sulfonic acid. It is represented by SO3H group, students. Clear, students? Okay. Now I'm going to do these questions. Let us make it a bit thick. Okay. First of all, we need to give the numbering. So from which carbon the sulfonic acid is close. So this is going to be first carbon. This is going to be second. This is going to be third. Now for 3 carbon atoms, what is going to be the word root? For 3, it is going to be prop. After 3, what we need to write? We need to write primary suffix. That is the bond between the carbon atoms. It is single bond. So ane will come. Now students comes what? Now comes secondary suffix, which is the functional group. What is the functional group over here? SO3H. Now here it is what? It is sulfonic acid. And I told you secondary suffix is going to be sulfonic acid. So we can directly write propane sulfonic acid or propane 1 sulfonic acid because it is present over the first carbon. Propane 1 sulfonic acid. Clear, students? Is there any primary prefix over here? No, because it is not cyclic. Is there any secondary prefix over here? No, because there is no extra group present over here. Now moving forward towards the next case. Question number 68C. Carbon, 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 carbon. While numbering, we will start from this direction because it is close to the functional group 3, 4, 5, 6 and 7. For 7 carbon atoms, what is the word root? It is hept. For single bond, it is ane primary suffix. Now, we need to write the secondary suffix. We know that SO3H is present over the third carbon atom. So, we will write 3 sulfonic acid. Now, if I talk about prefix, primary prefix is there or not? No, ma'am, because there is no cyclic chain. Secondary prefix is there? Yes. No, it is not there because there is nothing extra group over here. So, its naming is heptane 3 sulfonic acid. Clear, students? Okay. Now, if I move forward towards the next case, here in this case, what I can see is, okay, 1, 2, 3, 4, 5, 6, 7 carbons are there. So it is heptane 3 sulfonic acid. Now students, what come is this case, which is 69th question. I would say, see, why is priority order used here? Seniority order refers to as, we know that carboxylic acid was the topmost, second was sulfonic acid. Now if it is the topmost, it will be written in the secondary suffix as senior most functional group because it is senior most functional group. And you know that here SO3H group is also present, but it is after carboxylic acid in the seniority order we have seen. So it will be used as secondary prefix and is junior most functional group according to the priority order, seniority order. So that's why how we are going to do is you need to identify which of the following functional group will come under the category of secondary suffix and which will come under the category of secondary prefix. So COH will come under the category of secondary suffix because it is the senior most functional group, while SO3H will come under the junior most category because it is the prefix group. Now students, what we need to do is we also know how many carbon atoms are present over there. We need to mention this as first, second, third, fourth, 5, 6 and 7. Again 7 carbon atoms we use hept. Now there is a single bond between each carbon atom, so we will use ane. Now students, we have to write the secondary suffix over for this, not for this, for this because it is senior most. For carboxylic acid, it is included in the parent chain, we will use oic acid. Present on the first carbon, so no need to mention, E will get cancelled because vowels are there, heptanoic acid. Now, if I talk about the prefix, is there any cyclic compound? No, there is no cyclic compound. If I talk about secondary prefix, so I have, this is refers to as sulfo. We use sulfo for secondary prefix. This is chloro and this is bromo. So, alphabetically, B comes first. That means 3 bromo, 4 chloro, then is 5 sulfo, 5 sulfo, heptanoic acid. So this will be the nomenclature. It is quite different and very interesting also. Yes, students. Now comes the question number 70, that is naming of alcohol. Alcohol naming is quite simple, students. It is represented by OH group. What is the secondary prefix you use over here? We use secondary prefix as hydroxy. And secondary suffix is alcohol, that means ol, only ol, ol will come as a secondary suffix. Now students, we are going to do the nomenclature of these compounds as well. If I start over here, I would say this is first, this is second, this is third, and OH group is present over the second one, right? So how would I represent? First of all, word root for 3 carbon atoms is prop. Primary suffix refers to as the bond between them, that is the single bond, that is ane. Now, if I talk about the secondary suffix, that means the functional group, OH group. It is present over the second carbon atom. So, what we need to do? We know that propane ends with E and ol starts with O. So, E will not come over here. Propan, now mention the number. It is present over the second carbon atom. And what it is ol. Secondary suffix is ol. So, its name is propanol. Its name is propane 2-ol. Propane 2 2-ol. Clear? Now if I talk about this case, here also we are getting two groups, so we need to find out which is senior most, which is junior most. We know that carboxylic acid is the topmost one, so it will come under the category of senior most. If it is come under the category of senior most, it will be written in the place of secondary suffix, right? And it is not included in the parent chain, so we will write carboxylic acid. We will not write oic acid. Oic acid is written when it is included in the parent chain. So OH now will be used as a secondary prefix. Why? Because it is the junior most functional group. It is the junior most functional group. So for secondary prefix, for junior most functional group, what do we use as secondary prefix? Hydroxy. Now let us write this. First of all, we will provide the numbering to each carbon atom, and the carbon atom which is attached to COH will be provided first number because it is the senior most. Now 1, 2, 3, 4, 5, 6. For 6 carbon atoms, what is the word root? It is hex. Primary suffix is going to be ane because it is single bond. Secondary suffix, now we have written already, carboxylic acid will come. So at which position? First position, hexane 1 carboxylic acid. If I talk about prefix, is there any primary prefix? Yes, cyclic, because cyclic compound is there, so cyclo will come. Is there any secondary prefix? Yes, secondary prefix is there, hydroxy. It is present over which carbon atom? Fourth, so it will be 4-hydroxy cyclohexane 1 carboxylic acid. Clear? It is interesting. Kindly put a star over here. I hope so. Now you are able to, do nomenclature for the complex compound as well. Now in this case, this is our parent chain, 1, 2, 3. Now for 3 carbon atoms, we write prop. For single bond, we write primary suffix as ane. Now students, we have OH group on first, second and third. So we know that ol will come, so E will not come because it is a vowel. Now we will mention first, second, third. On all of the 3 positions, there is alcohol. Now for 3, we use tri. And for suffix, for alcohol, we use ol. So its name is going to be propan 1, 2, 3 triol. Clear? Very good. Now moving forward towards our 73 question. Look here, again we will mention all the carbon atoms as a number. First, second, third, fourth, fifth, sixth. Now word root for 6 carbon atoms, it is going to be hex. Primary suffix is going to be ane because the carbon-carbon contain what? Single bond. Now for secondary suffix, what we need to see is which group is present? OH group. Over how many carbon atoms? Again, for secondary suffix we use ol, so E will not come. Now it is present over first carbon atom, third carbon atom, fifth carbon atom. How many OH are there? 3. So tri will come. Now what is the suffix we use? Ol comes. Is it complete? No, it is not complete. Primary prefix is also there because it is a cyclic compound. So cyclo will also come in front of it. Its name will be cyclohexane 135 triol. Clear? Now comes this question. If I talk about this question, first of all, mark all the carbon atoms over here. We know that SO3H now is acting as a senior most functional group. Now, if it is acting as a senior most functional group, we will write it as sulfonic acid in the place of secondary suffix. If I talk about this OH group, this is now acting as secondary prefix because it is junior most and it is written as hydroxy when there is a comparison between two, functional groups. So first of all, we should mention the number of carbon atoms. It is 1, 2, 3, 4, 5, 6, 7. For 7 carbon atoms, we use word root as hept. Primary suffix is used as ane for the bonds between the carbon. Now we need to mention the secondary suffix, which is sulfonic acid, present over the 4th carbon atom. So we will write heptane 4 sulfonic acid. Now, if I talk about the prefix, students, if I talk about the prefix, is there any, I would say, is there any cyclic compound? No, it is open chain compound. It is open chain compound, students. So we no need to write primary prefix. What is the secondary prefix over here? It is hydroxy. It is chloro. It is bromo. So B comes first. That means we need to write this first. Let me write down. It is 2 bromo. Then comes chloro, right? Then comes 3 chloro, then comes 5 hydroxy, then comes this same thing, heptane 4 sulfonic acid. Okay, students, now let us erase this. Right. This is the name, right? Okay. So students, now we are doing the case of thioalcohol. Basically, we have seen alcohol is the OH group while thioalcohol is SH group. Now, the secondary suffix used for thioalcohol itself is thiol, and the secondary prefix used for thioalcohol is mercepto. Clear? Okay. Now students, we need to do the naming. You have the 75th question in front of you. How to do its naming? First of all, we know that this SH group, that is thioalcohol, is connected to this carbon, right? Let us put all the carbons in such a way. Now we have to number each carbon. So it is attached here. This is first carbon, second, third, fourth, fifth and sixth. The parent chain contains 6 carbon atoms. If a parent chain consists of 6 carbon atoms, what will be its word root? Its word root will be hex. Now after word root, what do we write? We write primary suffix. Primary suffix refers to the bond between the carbon atoms. Here carbon-carbon single bond is present, so we will write ane. Clear? Now what is secondary suffix? When functional group is present. Here our functional group is SH. It is which is known as thiol for the case of secondary suffix. So we will directly write hexane thiol. It is understandable that it is present on the first position, but when it is not present on the first position, there are one or more than one thiol you see, then you need to mention the numbers, right? Now students, we have done from word root towards the suffix portion. We will move towards the prefix one. Is there any primary prefix present over here? So yes, because it is a cyclic compound, here cyclo will come as a primary prefix. Now, if I talk about secondary prefix, that means extra group. Is there an extra group? No. That means its name is cyclohexane thiol. Clear? Okay, now I have this compound with me. Let us look to the question number 76. Here I have OH group with me as well as SH group. OH group refers to as alcohol and SH group refers to as thiol. Thioalcohol in other words, I would say. So you know that according to the priority order, OH has more priority as compared to this. So we will write secondary suffix for OH, for alcohol, and it is going to be ol, OL. And for SH, we are going to write prefix, secondary prefix. It is going to be mercepto. Clear, students? Now, to name it, we need to mention the number of carbon atoms. See, where OH group is attached, that is the senior most. So 1, 2, 3, 4, 5. Basically 5 carbon atoms are present in the parent chain, hence the word root comes out to be what? It comes out to be pent. Now you know that primary suffix refers to the single bond between the carbon atoms. That means ane will come. The next thing is secondary suffix. Secondary suffix now we have to use as ol, and we know that E and O can't come together because these are vowels. Hence E will be cancelled over here. You can write pentan 1 ol because it is present on the first position. If you are directly writing in pentanol, it is understandable that OH group is present on the first carbon. That's why you are not mentioning it. Clear? Okay. Now students, here this is a cyclic compound, so primary prefix will be used as cyclo over here. Now what is secondary prefix? Secondary prefix here is mercepto, which is present on which position? It is present on third position. So we will say 3 mercepto cyclopentan 1 ol. Clear, students? Okay, now we will move forward towards our next question, that is question number 77. But this question 77 is a category of aldehydes. So now we are doing IUPAC nomenclature of aldehydes and ketones. Students, aldehyde group is the one which is shown by CHO, or I would say C double bond OH. This is aldehyde group. And when I talk about ketone, ketone is basically C double bond O, like this. Okay, this is our ketone. Now what are the suffix and prefix that we use? For aldehyde students, secondary suffix is al, al, al. See, for alcohol it was ol, but for aldehyde it is al. So don't get confused. The secondary prefix for this is formyl or oxo. I will tell where to use formyl, where to use oxo. Now coming towards the ketonic group, secondary suffix we use here is on, O-N-E, on, and secondary prefix that we use here basically is keto or oxo. keto or oxo. Here is no such situation to use keto or oxo particularly, but for aldehyde, I will tell you where to use formyl, where to use oxo. Now, students, the very first case, that means the 77th question we need to see here is only one carbon atom present. The carbon atom, just like the carboxylic acid, will be included in the parent chain. Hence, it is one carbon atom. For one carbon atom, what will be the word root? It will be myth. It will be myth. Okay. After word root, what shall we write? We write primary suffix. That means the bond between the carbon atom. Now, here the bond is single bond. We are here to observe that this carbon is attached to this hydrogen by single bond. Hence, ane will come. Okay. Now, what is the secondary suffix? Secondary suffix refers to as what? Functional group. Here functional group is CHO, which I already told you is aldehyde, and secondary suffix will be written as al. So here again E and A can't come together because they are vowel. So it will come like this. So its name will be methanol. Clear? Okay. Now if I take this case again, I have 1 and 2 carbon. This is first carbon. This will be second carbon because functional group are given the priorities, right? So if I say here, how many carbon? 2 carbon. For 2 carbon, word root is ith. Right? Primary suffix is again going to be ane because it is a single bond. Ane. Don't get confused that here double bond is present. I am talking about carbon-carbon bond. Clear? Okay, here I was talking about carbon-hydrogen bond because it was a single carbon present here. So here ethane is there. Now comes the secondary suffix portion. Secondary suffix refers to as a functional group, and for aldehyde it is al. Again, E and A will not come together. So it will be ethanol. Clear? Now let us see this case. In this case, if I start from this direction, I will get the CH3 at the lowest position. But if I start from this direction, it is a farmost position. So I will say first, second, third, fourth, fifth, sixth. Total 6 carbon atoms are present. So what will be the word root for 6 carbon atoms? It is going to be hex. Now, after this, what is the primary suffix? See, there is a single bond between each carbon atom. So ane will come. Definitely. Okay. After that, we need to write the secondary suffix. Now we have 2 CHO groups. That means aldehyde groups. Secondary suffix is basically al. Okay. So we need to mention here E will be cancelled because vowel is there. First position, sixth position. 2 aldehydes are there. So di will come and then al will come. Hexane 1,6-di-al. Now is it complete? No, it is not complete because we still have the CH3 with us, which is used as a secondary prefix. So it is present at the third carbon. Here it will be 3-methyl hexane 1,6-di-al. Clear, students? Great. Now let us move towards next question. Next is 80th question. It is also quite interesting. Now see what happened here is this CHO basically is attached to this carbon. So this is first carbon, this is second, this is third, this is fourth, this is fifth, this is sixth. Now in this case, students, what happens is we have 6 carbons. So for 6 carbons, we write hex as a word root. We have all the single bonds. So we write primary suffix as ane. Then we know that, clearly listen to me, we know that this CHO basically is aldehyde group. So aldehyde group is represented by al. We know that easily that here al will come. But kindly see, this is our parent chain and this is our CHO group present over here. So we can write it as al. E and A can't come together, right, students? E and A will not come together. But according to the question, once you observe clearly all the concepts, here al will not come directly. Why it will not come directly? Because CHO is not involved in the parent chain. Here carbaldehyde will come. Here carbaldehyde will come. Why? Because it is not included in the carbon chain. When it was included in the carbon chain, we directly wrote al. But here it is not given. So here we will write carbaldehyde. Hexane 1 carbaldehyde, or directly you can write carbaldehyde. Sorry for the students. I shall write it down again. Hexane carbaldehyde. Okay, students. Now comes our prefix portion. Is it a cyclic compound? Yes. So cyclo will also come in front of it, right? Is there any primary prefix? Is there any secondary prefix? No. So its name is cyclohexane carbaldehyde. Now if I come across the structure, see, I can either go in such a way that these are included here. Okay, so if I go in such a way, I would say there are total 5 carbon atoms. So for 5 carbon atoms, we use pent. There is a single bond between each carbon atom, so we will use ane, right? Now comes the secondary suffix. We know that CHO is present at the first and the fifth position, and ul is going to come, so E is going to be cancelled out. First, comma, fifth, di-ul. Now students, we have this CHO left with us and it is not included. Clearly listen to me. This is not included in the chain. When it is not included in the chain, then you need to write formyl. This is formyl. At which carbon? Third carbon. So it is 3-formyl pentane 1,5-diol. But you can also write this compound in a different form. How? I'm writing it again. You can also write in this in such a way like this. Make this as your parent chain. When you are making this as your parent chain, this is first carbon, second carbon, third carbon. For 3 carbons, you write prop. Single bond is there, so primary suffix is ane. Now students, you know that these 3 are not involved, in chains. So we are going to write it as dash 1, 2, 3 dash tricarbaldehyde. So you can do either of the ways in which you want to do. You can see the options and you can correct it. Both are correct, right? Okay. Now I'm moving forward towards the 82nd question. Here, see. Here, what do we observe? We observe 2 functional group. One is COH, another one is CHO. And I know that carboxylic acid has the highest seniority order. So it is going to be the first compound. It is going to be second. It is going to be third carbon, fourth carbon, fifth carbon, sixth carbon, and seventh carbon. For 7 carbon, what is the word root? For 7 carbon, ma'am, it is hept. Now, what is the primary suffix here? Primary suffix is single bond, that is ane. That is ane. Now, what is the secondary suffix? Now, who will get the secondary most position? I would say this COH is basically the senior most functional group. So, we will write its secondary suffix. It is included in the parent chain. So, we will write oic acid directly. Right? So, here I know E and O can't come together because these both are vowel. And it is present on the first carbon. So, no need to mention directly. You can write oic acid. Heptanoic acid. Clear? Now comes the previous portion is primary prefix. Is there any primary prefix? No, because there is no cyclic compound. Secondary prefix, yes. Here this CHO acts as a secondary prefix. Now it is included in the chain. It is included in the chain. When it is not included in the chain, we are writing formyl. But when it is included in the chain, we write oxo. So you got to know where to use oxo and where to use formyl. Now it is present on the 7th carbon. So I will say 7-oxo heptanoic acid. 7-oxo heptanoic acid. Kindly take note, when it is included in the parent chain, oxo will come as a prefix. When it is not included in the parent chain, formyl will come as a secondary prefix. Clear, students? Okay. Now we shall move forward towards the 83 question. Look forward to this question. It is quite interesting. And the previous one also, kindly put a star over here because it is a different concept that you got to know. So here, students, here what we need to understand is, we need to understand that COOH basically, has the seniority order than CHO group. We know that. So this is going to be the first carbon, this is going to be second, this is going to be third, this is going to be fourth, fifth, and sixth. Right? This is our parent chain. So let us do first of all 6 carbon atoms. What will be the word root? Hex will be the word root. Each carbon atom has a single bond with itself, so primary suffix is going to be ane. Okay. Now secondary suffix for COH, we know that it is the senior most position, so secondary suffix is going to be what? It is included in the parent chain. No ma'am, it is not included in the parent chain. Then what will we write? We will write directly carboxylic acid. Hexane carboxylic acid. Now you can write the number also here. Like hexane 1-carboxylic acid, you will get to know. Here we will not use oic acid because it is not included in the parent chain. So don't get confused. When it is included in the parent chain, we are writing oic acid, but when it is not, we directly write carboxylic acid. Clear? Now students, it is a cyclic. So the prefix will be used here as cyclo. Now what will be the secondary prefix used here? Secondary prefix now. This is the extra group. Yes, ma'am, this is the extra group. See, it is attached to this carbon. That means this is first carbon, second carbon, and third carbon. If I name this separately, CHO is involved, CHO is involved in the ring, in this ring automatically. Then we can write it as 3-oxo-propyl. If I name it separately, right? So it is present over, which carbon atom? Third carbon atom. So what we will write? 3 dash bracket starts 3-oxo-propyl bracket close cyclohexane carboxylic acid. Because it is involved in this chain, it is oxo. When it is not involved, it is formyl. Clear? Okay. Now I take this example of ketone. It is simplest. 1, 2, 3. Okay, now for 3 carbon atoms, the word root is going to be prop. Carbon contains single bond, so it is ane. And we know that for ketone students, we use secondary suffix as one, O-N-E. O-N-E, don't say one, it is one. So the name is going to be propanone. Propanone. Now you will say, ma'am, why have you not mentioned on the second? See, listen to me carefully. Ketonic group is like this. So it means that it will be present at the center. One group is here, one group is here. And propane contains 3 carbon. That means it is present at the center. So I'm directly writing it as propanone. Now comes the next case here also. 1, 2, 3, 4, 5. Now for 5 carbon atoms, we write pent. Single bond is there, so we write ane, right? Now again, here ketone is present on the 3rd carbon atom. So what we are going to write? Very sorry, students. Okay, very sorry. So here it is present on the 3rd carbon atom. So we are going to mention it here. E will not come again. I'm going to tell you. It's 3-one. Pentan 3-one is going to be the name of this compound. Now let us move forward towards our 86th question. See here also. Now students get confused by looking at the structure. It is so difficult. No, it is not at all difficult. You need to just understand the basic difference. See. It is somewhat like this. And if I represent carbon atoms over here, students, I would say this is carbon, 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 carbon. And here oxygen is also there. So this is something which ketone group has. This is something which ketone group has. This is first carbon, this is your second carbon, this is your third carbon, fourth carbon, fifth carbon, sixth carbon. So how would you name it? First of all, primary prefix comes cyclo, then comes hex for 6 carbon atoms, then comes single bond for ane, and then comes one. So it comes out to be cyclohexanone. It comes out to be cyclohexanone. Now let us see the next case, students. Let us practice now question series. We are practicing questions, but now the questions that you are going to get are the mixed questions based on the functional group, based on the simple alkanes, alkenes, alkynes. All of these stuff are now mixed up and given to you. So we will start this, and I want everyone, each one of you, to first of all identify your problems. Learn to identify your problems. Give your power to solve them also. Okay, give yourself so much power and ability that I can do this question, so that you can learn from your mistakes. Okay, now students, let us move towards question number 87. This is 87th question, as we have been doing so many questions. So 87th question says that the systematic name of CH3CHBr CH2OH is. You need to tell its name. A option is 3-hydroxy-2-bromopropane. B option is 2-bromopropanol 1. C option is 2-bromo-3-propanol. D is 3-hydroxy-isopropyl bromide. So first of all, we will write the structure here. Our structure is CH3CH, which is further attached to Br. Then comes CH2OH. Clear? Clear? This is the case. Now, first of all, we need to mention the number of carbon atoms. Here, OH group is attached, so this carbon is first, this is second, this is third. This is our parent chain. Now, to represent parent chain, we know that there are 3 carbon atoms. So, what will be the word root? It will be prop. It will be prop. Now, what will be the primary suffix here? Carbon. Carbon contains single bond, so ane will come. Right. Now, what will be the secondary suffix? For functional group, it is referred to as, now here it is OH. OH is our alcoholic group. What is the secondary suffix used for alcohol? It is ol. It is used as ol. So here E and O are vowels, so it will not come. We will write it as 1-ol, or directly you can write it as propanol. It is Same thing. Propanol or propane 1-ol is one thing. Now students, other thing which is left is there any primary prefix? No, because it is not cyclic. Is there any secondary prefix? Yes, this Br. It is present on the second carbon, so we will write 2-bromo propan 1-ol. Once you see the options, in one of the options you can see this, they have written the one number in front of it. So no need to panic. In some of the cases it is written. It is the same thing. See, if we see the first, first case, it is 3-hydroxy. No, it is not at all possible. Hydroxy is not at all possible here. You know that because OH is the only functional group present here. So we will use it as a senior-most functional group and we will give it the position of secondary suffix. So this is wrong. 2-bromo propanol 1. 2-bromo propanol 1. So I told you they somewhat sometimes write the number in front of backside, but it is the same thing. Hence I would say that option number B is correct. But still we can see the other options. 2-bromo 3-propanol. No. Is alcoholic group on the third carbon? No. So this is wrong. Now D option, 3-hydroxy. Again, hydroxy can't come. So which option is correct, students? Option number B here is our correct. Option number B here is our correct. Kindly put a star over here for the answers. Okay. Now I am representing answers by the star, or we can take another thing. Star is kept for the constant. Okay. I am taking this. This is our answer, right? Now let us move towards our next case. Next case is IUPAC name of the CH3 twice. CH3 twice is. First of all, we have 4 options. A option is 1,1,2,3 tetramethyl ethane. B option is 1,2-di isopropyl ethane. C is 2,3-di methyl butane. D is 2,3,3 trimethyl butane. So students, what we need to do is, first of all, we need to make the compound. It is CH3 twice, which is present on this carbon atom. Right? Then we have again CH, and here also 2 CH3 are attached. So now first of all, make a parent chain. It is 1, 2, 3, 4. This is our parent chain, students. This is our parent chain of 4 carbon atoms. For 4 carbon atoms, what will be the word root? It will be but. Now what is the primary suffix here? Primary suffix refers to the bond between the carbon and carbon, which comes out to be single bond, and it comes out to be ane. Now what do you mean by the secondary suffix for the functional group? Is there any functional group? No, there is no functional group present. So secondary suffix is not used. What will be the primary prefix here? Primary prefix is also not used, ma'am, because there is no cyclic compound. What is a secondary prefix? The extra groups. Methyl, methyl. They are present on second and third carbon. So I'm going to write 2, 3 dash. Di is used because 2-methyl are present. Dimethyl butane. Now let us see the option which it matches. So if I see, it matches the option number C. It is option number C. Answer is option number C. Students, all of these questions are taken either from the previous year or from different books. So I am making you practice a lot of questions. Okay. Now let us see the next question. Next question is the IUPAC name of the following compound is. There are 4 options. A option is 4-ethyl 2-pentanol. B option is 4-methyl 2-hexanol. C option is 2-ethyl 2-pentanol, and D is 3-methyl 2-hexanol. Now first of all, we need to write it. So, okay, CH3, CH, CH2, CH3. Here it is CH2, CH, we have OH attached to it, and we have CH3. Now we know that we need to make a maximum number of carbon atoms as our parent chain. So if I start from this direction, I'm getting alcoholic group on the second carbon, right? 4, 5, 6. Now what is our parent chain? Our parent chain looks like this. This is our parent chain, right, of 6 carbon atoms. Now the word root for 6 carbon atoms is going to be hex. What is primary suffix? It is ane, because there are single bonds, so ane will come. Now what is secondary suffix? For OH group, we write ol. It is present on the second carbon, and we know that ol and E, O and E are vowels, so it will not come. It is present on second, so 2-ol, hexane 2-ol. Okay, other than this, is there any primary prefix? No, ma'am, because it is not cyclic. Okay, secondary prefix, yes. Extra group is present over here. You can see very clearly this CH3. It is present on which carbon atom? 4th. So we can write 4-methyl hexane 2-ol, 4-methyl hexane 2-ol, or you can directly say 4-methyl 2-hexanol. It is the same thing. So option number B is our correct answer. Is going to be option number B, students. Kindly put it in a box. Option number B is our correct answer. Right? Okay. Now let us see the next question. The next question is IUPAC name of CH3CHOH CH2CH2COH is. Now we have two functional groups over here. One is carboxylic acid, other one is alcohol. Now let us draw it first. CH3 CH, it has OH attached with it. Then we have CH2, then we have CH2, then we have COOH. Now see, students, this is going to be our parent chain. It is going to be our parent chain. If I number these carbon atoms, this is the first because it is the senior most, second, third, fourth, and fifth. So word root contain 5 carbon atoms. That means for 5 carbon atoms, we are going to write pent. We are going to write pent. Now, there is a single bond present between all the carbon atoms. So we can write AN here. Right. Now we know that secondary suffix here will be used for whom? For carboxylic acid. Secondary suffix. And what do we use here for carboxylic acid? When it is included in the parent chain, we write oic acid. We write oic acid. So here oic acid starts with O and pentane ends with E. So E will be cancelled out. Oic acid will come directly. You can also write pentan 1 oic acid. It is the same thing. Now comes the primary prefix. Is there any primary prefix? No, because there is no cyclic compound. Is there any secondary prefix? So yes. We have OH with us. When it acts as a secondary prefix, students, because it is a junior most functional group, we write it as hydroxy. So it is present over the 4 carbon. We can write 4-hydroxy pentanoic acid. Right. So if I see the options here, I can see it is option number A, 4-hydroxy pentanoic acid. Answer is going to be option number A. Let us put it in a box. Okay, now let us move towards our next question, students. Next question is question number 91. I have the IUPAC name of CH3OC2H5 is. Students, here you have again 4 options. A option is basically ethoxymethane, B is methoxymethane, C is methyl ethyl ether, while D is ethyl methyl ether. So ether is the one which have 2 alkyl groups beside it. So like this oxygen is going to have one group here and another group on the other side. So students, now we have to see the maximum number of carbon as our parent chain. So here we see 2 carbon atoms. That means the parent chain will contain eth. Right. So for ether we use oxy word, like if it is 1 carbon we will use methoxy, if it is 2 carbon we will use ethoxy. So parent chain is here of ethane, while CH3 has the lowest number, so it will be methoxyethane. It will be methoxyethane here. It will be methoxyethane. So option number B will be our correct. You can see the table that we have studied in the priority order so that you can learn the suffix as well as prefix. So whenever you get such groups, the highest one will be referred to as your parent chain, which is eth. Single bond is there, so ethane. So the furthermost, that is the prefix one, here will be used as a methoxy. Clear? Okay. Now if I see the next question, I have the IUPAC name of CH3C triple bond N. Now this is what? This is a cyanide group. I have already told you. Now if I write it in such a way, CH3 single bond C triple bond nitrogen. So here these both will be counted. This carbon is first carbon, this is second carbon. So word root is going to be, for 2 carbons it is going to be eth. For 2 carbons it is going to be eth, students. Now there is single bond, so it will come as ethane. Now as you have seen the priority order, or you have seen the functional group, where there I have already told, for this we use secondary suffix as nitrile. So it will come as nitrile. Ethane nitrile, that means option number B is going to be the correct answer. Answer is going to be option number B. Clear? Okay. Now let us move towards the next question. The IUPAC name of CH3. Here students, this C will not come. It is by mistakenly written. CH3 C double bond O C2H5 will be. Now you have again 4 options. A option is ethyl acetate. B option is ethyl ethonate. C option is methyl propanate, and D is none of these. So students, basically what happens is, this is CH3CO. I would say that what it is, it contains 2 carbons, so it is ethyl, and when it is further attached with this structure, basically this arises as an onate, you know. So here again 2 carbon atoms are present, so it is again ethyl ethonate. You will say that ma'am, it is also known as ethyl acetate, but that is the common name, but we need to identify the IUPAC name. So option number B will be our correct answer. So if I move towards the next question, that is question number 94, it is in front of you. The IUPAC name of this compound is, A option is 1-methyl 1-aminopropane, B option is 2-aminobutane, C option is 2-methyl 3-aminopropane, and D is none of the above. So students, first of all we need to write this CH3 CH2 CH CH3 NH2. So now kindly see this. We need to identify the carbon atoms. It is first, it is second, it is third, it is fourth. This is going to be our parent chain, right? Now for 4 carbon atoms, the word root comes out to be what? It comes out to be but. They have single bond, so ane will come, students. They have single bond. Carbon are basically having single bond, so ane will come. Now here we have what? We have NH2. NH2 here act as a prefix, so it is present at the second number, so it will come as 2-aminobutane. That means option number B is going to be correct. Option number B is going to be correct. Okay, now I'll come towards the next part. Next question is 95th question I have in front of you. CH3 CH CH3 CH3. It is most simplest, I guess, right? See, 1 2 3 parent chain contain 3 carbon atoms, that means it is prop. They have single bond, that means primary suffix is ane. What is secondary suffix over here? No functional group, no secondary suffix. What is primary prefix here? Nothing, because it is an open chain compound. What is secondary prefix over here? It is CH3 we have on the second carbon, so it is 2-methyl propane, which is going to be your option number C. Answer is going to be option number C. Clear, students? Okay, very good. If it is clear to you, I hope so you're enjoying all the questions and now you're able to solve also. See, some questions might be, you think that it is quite difficult, but they are not, students. It will be easy for you when you will practice it, because practice will make you perfect. Not to the very first time you're going to attempt all the questions correctly, but yes, when you'll practice more and more times, no, from different books, from the DPP which I'm going to give you, there will be a lot of questions. Do practice the DPP. But yes, do not forget, again I'm repeating, at the end of the video, I want each student to write in the comment section that ma'am, I did this much questions and I secured this marks. For each question, you will provide yourself +1 marks. And I want to know which student got how many marks. I want your name and your marks. The total questions I'm going to tell when we'll be that at the end of the question, last question, I will tell you these are the total questions. Kindly give yourself marks and give yourself applause for that you have done something today. You have learned something today, right? And students, if any of the student, feels like, no ma'am, I was unable to do so. So don't get demotivated. When a small child is born, he or she starts to move. He or she falls many times, students. But one day the children itself starts to move. Why? Because he want to move. He want to do it. He want to show the movement. He want to, run here and there. So that process is what? It is a slow step. You will fall, you will rise up again. You will fall, you will rise up again. I want you people also, when you are falling down, keep it a signal in your mind that this time I am failing, this time I am falling down, I have to rise up again. I have to prove to myself that no, I can do this. There is nothing impossible in this world. You know that impossible itself says I am possible, right? So students, moving on to the 96th question in front of you. It is very easy. Let us do here only. Okay, this Cl is there, so we will start from this side only. 1, 2, 3, 4. Word root is of 4 carbon atoms, that means it is but. Each carbon contains single bond, so primary suffix is coming out to be ane. Now secondary suffix here is nothing because there is no functional group. Now we have prefixes. What will be our primary prefix? It will be nothing because it was open chain. Now secondary prefix, ma'am, we have methyl with us and chloro with us. So C comes first, so we will write it first. 1 chloro, 3 methyl, butane, 1-chloro, 3-methyl butane. Let us check which option is correct. So option number A is our correct answer. Option number A is our correct answer. Okay, now let us move towards our next question, 97th question. Let us see, it is a double bond case. Okay, here students, I'm solving it here only. Double bond is here, so I will start numbering from this direction. 1 2 3 4 5. The parent chain contains 5 carbon atoms, so the word root is going to be pent. Now, here double bond is observed between first and second, so I am going to write pent 1-ene. You can directly write pentene. It is clearly that whenever double bond is present, it is present on the first carbon atom when it is not mentioned, right? Now, is there any secondary suffix? No ma'am, there is no functional group. Is there any primary prefix? No ma'am, because it is open chain compound. Is there any secondary prefix? Yes ma'am, there is a CH3 group present over the fourth carbon atom. So, 4 methyl pent 1-ene or pentene directly. I would say, let us see through which it is matched. B option will be correct. They have written 1 at the end, but it is the same thing, right? So answer is going to be option number B, my dear students. Okay, option is going to be B. Now let us see the next question here. We have, which of the following alkane contains primary, secondary, tertiary and quaternary carbon atoms together? Now you know what is primary carbon. Whenever carbon atom is attached to one single carbon atom, it is primary. When it is attached to 2 carbon atoms, it is secondary. When the carbon atom is attached to 3 carbon atoms, it is tertiary. And when it is attached to 4 carbon atoms, it is quaternary, right? Okay, so now let us see all the cases. The very first case, CH has 3 CH3 with it, right? So see students, this carbon is attached to a single carbon. So this is 1 degree carbon. This carbon is also attached to 1 carbon. It is also 1 degree carbon. This carbon is also attached to 1 carbon. So it is 1 degree. This carbon is attached to 3 carbon, students. So it is basically 3 degree carbon. They told that you need to tell a compound which have all the carbons together, 1 degree, 2 degree, 3 degree and 4 degree. So it doesn't have, it is wrong. If I talk about B, let us draw it here. CH and we have C2H5 thrice. We have C2H5 here thrice. C2H5, C2H5, C2H5. Okay. Now if I open up C2H5, kindly look into the structure. CH, CH2, CH3, CH2, CH3, CH2, CH3. Clear students? Now see here, we need to find the degree. If I talk about this carbon atom, it is further attached to 3 carbon atoms, so it is 3 degree. If I talk about this carbon atom, it is attached to 2 carbon atoms, so it is 2 degree. If I talk about this carbon atom, it is attached to 1 carbon atom, it is 1 degree. If I talk about this carbon atom, it is attached to 2 carbon atoms, so it is 2 degree. And if I talk about this, it is attached to 1 carbon atom, so it is 1 degree. Now students, this carbon atom is attached to 2 carbon atom, it is 2 degree. It is attached to 1, so it is 1 degree. But in this case, students, 4 degree carbon is not present and we need to identify all the carbon atoms. So B option is also incorrect. Now comes the C part. Let us draw this. C has again CH2. It has CH. This CH has 2 CH3. Here this C contains 3 CH3. One is here, another one is here, another one is here. Now let us identify all the carbon atoms. See, this carbon atom is attached to 1 carbon atom, so it is 1 degree. This carbon atom is attached to 4 carbon atoms, so it is 4 degree. This carbon atom is attached to 1 carbon, so it is 1 degree. It is attached to 1 carbon, so it is 1 degree. This is attached to 2 carbon atoms, so it is 2 degree. If I take this case, this is attached to 3, so it is 3 degree. I guess there is no need to solve it further because it has 1 degree, it has 2 degree, it has 3 degree, it has 4 degree. Hence, our answer is going to be option number C. Answer is going to be option number C. Clear? Okay. Now let us move towards our next case, the question number 99. We are approaching towards the 100 question, right? So the number of tertiary carbon atoms in the compound is, now we have been given this compound, we need to find tertiary carbon. What is tertiary carbon? Tertiary carbon is basically 3 degree carbon, the carbon which is attached to 3 carbon atoms further. So now let us draw this structure. We have this CH, it is attached to 2 CH3. Then we have CH2 here. Then we have C. It is attached to 3 CH3. Okay, we need to find number of tertiary carbons. We need to see the carbon which is further attached to 3 carbon. This is attached to 1 carbon, so this can't be. This is attached to 3 carbon. See, this is attached to 3 carbons. We have this as a tertiary carbon. This is 3-degree carbon. Okay, this is attached to 2 carbons, so this is not. This is attached to single carbon. This is not. This is attached to single. It is also single. It is also single. This is attached to 4 carbons. It is not. How many 3-degree carbon? Only one. Only one. So option number C will be our correct answer. Answer is going to be option number C. Now is the question number 100. Let us see 100 question. What does it says? Write the IUPAC name of this. IUPAC name of this compound. Okay. I want you all to solve it first. I will solve it at last because it's the 100 question. Let us do something interesting. I want you to comment in the comment section its answer. But you can check it with me in this video lecture only. At the end, I'm going to solve the 100 question. Okay. So, first of all, I'm going to read it for you. Write the IUPAC name of this compound. A option is 6,6-dibromoheptane 2-ol. B option is 2,2-dibromoheptane 6-ol. C is 6,6-dibromoheptane 2-ol, and D is none of these. Students, I want you to do this question correct. I want this answer as well, and I want your marks also in the comment section. Okay, you can check this in the video only. Now moving towards the next part. 101 question. I have in front of you the IUPAC name of this compound. We need to tell the IUPAC name of this so big compound, right? Okay, no need to worry. Let us do numbering. We will do numbering in which direction branching is near. So it is 1, 2, 3, 4, 5, 6, 7, 8. So the word root should be oct for 8. Let us see which have oct. It has oct. It has oct. It has oct. It has oct. Now we will do from the options. It will save our time. We will learn to do in a different manner also. Word root is right. Now comes primary suffix. It should be ane because each and every one has single bond. So octane will come. Octane. Octane. Okay. Octane. Octane. Okay. Is there any secondary suffix? No, because there is no functional group. Okay. Now comes the prefix portion. It is an open chain compound. So primary prefix is not present. Secondary prefix. We have methyl group over here and we have this group over here. Okay. Kindly, separately, do the naming of this. It is attached to this carbon. So it is first carbon. It is second carbon. So how do we name it? We have 2 carbons. So we will write it as ethyl, and here CH3 is present on the first carbon. 1-methyl ethyl. I'm going to write it in a proper way. It is 1-methyl and the parent chain is of 2, so ethyl. It is 1-methyl ethyl, students. Now it is present on the 5th carbon atom and it is present on the 3rd carbon atom. We should know the naming. Now see, 3 is the methyl, so first 3-methyl will come. Then it will come, both of these starts with methyl, but it has ethyl with it. So it will come first. So 3-methyl, let's check. Here 4 isopropyl. No, isopropyl namings are done in the common name. So this is wrong. Here 3-methyl is there. Yes, we have 3-methyl with us. We have 3-methyl with us. 6-methyl, not possible. Not possible. Now the next step is 5th carbon should have. 5th carbon, here isopropyl, again common name is not allowed. 5th carbon should have, what it should have? 1-methyl ethyl. So option B will be our correct answer. Answer is going to be option number B. Let us see the next case. That is question number 102 in front of you. Here it is very simplest. See. It will be first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, seventh carbon, eighth carbon. Again, I am going to see from the options only so that we can practice by both ways, right? For 8 carbon atoms, what is the word root? It is oct. It is oct. It is oct. Here it is heptane. It is not possible. It is oct. Clear? Okay. Now, all of these contain single bonds. So, octane should be there. Okay. Octane. Octane, octane. Okay. Now, before the word root, what should come? Primary prefix. For cyclic, primary prefix is there, but for acyclic, it is not there. It is acyclic open chain, so no primary prefix. Now, secondary prefix. See here, students, here this is also carbon atom. That's why I told you, please consider bond line notation. This is 2 carbons. That means this is ethyl. And this is a single carbon. That means it is methyl. So, alphabetically, E comes first. That means 4 ethyl will come in the very start. 4-ethyl, this is not possible. Here 3-methyl, this is not possible. Here 4-ethyl is there. After that 3-methyl. So which option will be correct? Option number B will be our correct answer, right? Okay, now let us see the next question. Okay, this is your 103 question. I guess there is something wrong in the numbering. Okay, yeah, here it is, 103 question. Okay, so for 103 question, what you need to do is you need to write the condensed formula and the bond line formula for the following. Write the condensed formula. The condensed formula is already shown to you. You need to write the bond line notation for this condensed. You need to write for this condensed formula. So kindly correct the question. You need to write the bond line formula for this. So we need to express with bond. This is our first carbon. Then there is a bond with second carbon atom. Then you know what? It is further attached with CH3. So I have shown it like this. It is attached to CH2. It is attached to CH2. And this CH2, this carbon is further attached to OH. So it basically looks like this. Clear? Okay. Now if I draw 104th question in such a way, first of all, I am having this carbon atom. This carbon atom, you know, is, first of all, I am showing carbon, is bonded with carbon atom. It is further bonded with carbon atom. It is further bonded with carbon atom. It is further bonded with carbon atom like this. In such a way. You can show in such a way also, students. It is COOH. I can show like this, right? Let me count the carbon atoms. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, you can do this. It is right. It is not wrong. It is 5. Clear? Or what you can do is here. Let me show you how you can represent it more accurately. Wait. We can start like this. This is the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, which has double bond O, then we have OH. This is the correct way to represent it, right? And we have NH2 also here present. So this carbon contains NH2. So here NH2 will come. Clear? Okay. Now if I have this case, you can do in that case also, but it looks very odd. So I have written in like this position. Okay. If I make here CH3 attached to CH2, attached to CH, further attached to Br. This is attached to CH2, CH2 attached to CH2, CH2 attached to CH3. Clear? Okay, students. Now coming towards next question, which is 106 questions. Number of sigma and pi bonds in the given compound is. Now, sigma bond is the single bond. So let us count. First of all, let us see the hydrogens. 2 plus 3, 4. 2 plus 3, 2 plus 1, 3. 3 plus 1, 4. 5. 5 and 6. 6 are the bonds with hydrogen. Other than this, we have the single bond also, na? 3, 4, 5, 6, 7, 8, 9, 10, 11. How many sigma bonds? 11 sigma bonds. Okay. How many pi bonds? Second bond and third bond are pi bonds. So 1, 2, 3 and 4. So 4 pi bonds are present. Hence, we will say option number B is our correct answer. Option number B is our correct answer. Let us see the next question, students. So, here you need to calculate the unsaturation number of the following compounds. That means the degree of unsaturation. So, let us start. We have been given the molecular formulas. There were two rules. One was the molecular formula, another was structural formula, right? So, for molecular formula, the formula was du is equals to number of carbon atoms plus 1 minus number of hydrogen atoms plus halogen atoms minus nitrogen atoms by 2. If there is any oxygen or sulfur you are getting in any of the cases, they should be neglected. So, I am starting this one by one. 107th question I am doing. Du is going to be how many carbon atoms? 6. So I will say 6 plus 1 minus how many hydrogens are there? 5. 5 plus halogen is 0, nitrogen is 1 by 2. So if I am going to solve it, 6 plus 1 is 7 minus 5 minus 1 is 4, 4 by 2. It comes out to be 7 minus 2, which is 5. So degree of unsaturation here comes out to be 5. Now let us take the case of 108. If I take 108, again I am going to use the same formula. Du is equals to how many carbon atoms? 5 carbon atoms. So carbon atoms plus 1 minus how many hydrogen atoms? 6 hydrogen atoms plus how many halogens? Br is a halogen, 2 halogens. Nitrogen is there? No. So minus 0 by 2. Let us solve this. It is going to be 5 plus 1, 6. 6 minus 8 by 2. 8 by 2 is 4. That means 6 minus 4 is 2. So degree of unsaturation comes out to be 2. Now let us see the next case. 109. Here in 109, again, du is equals to, here, carbon is 6 plus 1, then is minus, hydrogen is 8 plus halogen is 0. You know, nitrogen is also 0 by 2. Oxygen should be neglected. I already told you, students. Oxygen should be neglected here. Also, kindly correct the formula here. O2 will come. But oxygen is neglected, so there is no need to do so. So here I would say 6 plus 1 is 7. 7 minus 8 by 2 is 4. So 7 minus 4, it comes out to be 3. So degree of unsaturation comes out to be 3. Now for the case of 110th, let us see. Again, this formula, degree of unsaturation is equals to carbon is 20. So 20 plus 1 minus how many hydrogens? 21 plus how many halogens? 0 minus how many nitrogen? 1 divided by 2. So 20 plus 1 is 21 minus 21 minus 1 is 20 by 2 again. So it is 21 minus 10. That comes out to be 11. So degree of unsaturation comes out to be 11. So students, before ending this video, I have told you to do a question that was question number 100. Okay, I have this question. I hope so. You have already done this. Let us check the answer. Now, first of all, we will make one carbon chain. See, if I'm going to make a carbon chain in front of you, what I need to see is OH should be given the priority first of all. So first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, seventh carbon. For 7 carbons, what it is going to be our word root? Hept. Let us check. Here also hept, hept, hept. Here none of these, let us cancel it first only, right? Okay, now we have all the single bonds. That means heptane will come, heptane will come, heptane will come. Now after this secondary suffix, that means the functional group, which is OH, which is attached to second most position, and for this secondary suffix is used as ol. So 2-ol will come. Okay, 2-ol is here, 2-ol is here. Here is 6-ol. It is wrong. Now students, we have done the word root, we have done the suffix, comes the prefix. Is there any primary prefix? No ma'am, there is no primary prefix. Okay. Is there any secondary prefix? Yes ma'am, there is. Here it is Br and Br. Br is referred to as bromo. It is present on the 6th position. So let us see 6,6-dibromo heptane 2-ol. This is going to be the correct answer. But if I see students, I see C option is also the same. C option is also the same. So A and C, which you have done, it's correct, right? Okay, students. So our today's lecture is over. Here we have, completed total 110 questions. As I already told you that I am going to tell the total number of questions at the end of the video, and you have to comment in the comment section with your name how many marks you have secured. And trust me, if you are securing less marks, no need to feel so ashamed that I have got less marks, I don't know how to do so. Keep trying, don't quit, keep trying, don't stop. Keep moving. There is always a way, students. There is always a way. And the way is that will bring you with the help of practice. For once, you were not able to do so. But when you will practice, open these questions again. Try to do these questions again. And I assure you that you will do all the questions within a few seconds, just by looking with a simple basic formula for suffix and for prefix. So now we have completed our IUPAC nomenclature topic of organic chemistry here. I want all of you to write in the comment section how did you like this lecture of mine, and I want you to write your marks as well. So we will meet in the next lecture with a very interesting topic. Till then, students, keep smiling, keep learning. Thank you so much.